And I just find nobody who's skeptical. I'm actually not very persuaded by the arguments, even on like a naturalist evolutionary perspective. I'm like I don't know if the arguments are that compelling for thinking that they're aliens. But that's another story. I don't mean to.
I wonder if it would depend on like if according to like evolution and globe.
Hey everybody, tonight we're debating flat Earth versus globe Earth, and we are starting right now with the globe Earth side. Thrilled to have you here, Mark and David. The floor is all yours. In particular, Mark, glad to have you back.
Thank you so much, James, and it's a pleasure to be here. Thank you for joining me, and I will just share my screen for James. If you could be so kind, I would appreciate it. Thank you so much.
Deal.
Good morning or evening, whatever the case may be. I'm in the negative position of the Earth being flat. Now, I just have some questions, and I'll skim through this so David's got some time to respond. But I really want to have some questions for the flat Earthers on how these things work. First, the first question is circumpolar star trails. Now, this is sort of northern hemisphere. We can see that the star trails are going in one direction. Yep, if my video would, yeah. So circumpolar stars are going in a anti-clockwise direction. Southern hemisphere, they're going in the opposite direction. Now, I've heard it said before by flat earthers that they're all going north to west. But the problem with this, east to west, and the problem with this is that if the stars are circular, and this is southern hemisphere, they're going clockwise. They are going east to west up here, but not here. They're going the opposite way and north-south, right? So exactly how is this working? That's north, south, east, west. How is that exactly working on a flat Earth? How does that work? And I would really like to know, like, how are they traveling in the same direction? This is a comparison of all three perspectives: north, equator, south. And do keep this in mind that they do vary going in a straight line at the middle, and they rotate in a different way. This is a photo from Alaska. Notice how the central part is a lot higher the more towards the poles of the Earth that you get. This is from the South Pole. That is a LIGO laser. Notice it's almost vertically above the subject. That's somebody pointing a camera straight up. Why does that happen on a flat Earth? If they can explain that, that'd be great. Now, this is the flat Earth. Why is it that we see the circumpolar stars south from Australia, south from South America, and south from Africa? And there's no lateral movement through here. There's no lateral movement of the circumpolar stars. How do they jump from this area to this area by nighttime? How are they doing that? That's a question for the flat earthers to answer. Hopefully they'll have a wonderful and pertinent answer. This is how it works on a globe Earth, because basically what you're seeing is the circumpolar stars up here doing the rotation down here, and somebody looking from the south, somebody looking from the north, and they will travel in opposite directions. Let's have a look at that. James, how long have I been going for? Fantastic. Okay, so that's how it works on a globe. Now, I would love to see them explain it on a flat Earth, and you can see straight at the equator, one direction up the top. And as you go further,
he's muted.
Sorry about that, Mark. I accidentally muted you if you can hear me.
I think it says still muted.
He's still muted.
Let's see. I clicked ask to unmute. So Mark, I think you'll have to you'll have to click.
Oh yeah, it appeared in a weird place. Sorry, it appeared on my other screen. I didn't notice it.
Sorry
yeah, so
notice
that they're vertical at the equator. They're horizontal at the equator. As you go up towards the poles, they become more and more vertical till at the poles they're straight above you. Exactly what we see in every single case of people observing this. Now, I just want to go to lunar eclipses. What I want to know from the other side is why lunar eclipses are always curved, no matter what position the sun and the moon are in, always curved. If they could show me a picture of a lunar eclipse where the shadow is not curved, where it's straight across the moon, that would be great. But why from any direction, any orientation, any configuration, does the moon always have a curved shadow on it? And why does no one ever observe the flat plane, even when the sun is directly behind the Earth, to make this shadow? That would be great. This is how it works on a globe Earth. Very, very simple. The Earth is in between the sun and the moon. The Earth blocks the light, and that is why there is a red eclipse on the moon sometimes. Very, very easy. Why does the moon never change size? Why is it always when it's here, it should seem a lot bigger than when it's over here? But that never happens. That never happens. And why? Why is that? Why does it never change size? And I'll pass it over to David for taking too much time, but I really would like those answers from the flat earthers today. Cheers. Thank you.
All right. Amazing. Much of what you presented is on a level higher than what I would have presented, especially considering I don't have the familiarity with presenting the technological diagrams on Zoom yet. So I'm going to add to Mark's questions. So you have, for instance, with the circumpolar star trails, those trails, the orientation and the direction, it changes gradually based upon your latitude. So magnetic or optical or any other distortions that are postulated as a flat earth root cause would have to be aligned with our position based upon our latitude, and it has to somehow explain everything north of the equator, even though the same effect occurs as you go south of the equator. So there's no way to say, well, the northern hemisphere or the southern hemisphere has a distinction from the other, because the effect is the same. It's just that the orientation and the direction is flipped. With the solar position relative to the stars, we don't seem to get a clear explanation as to how you can have a so-called close sun and close moon, even if the stars themselves are considered close. And the effect is that when you're looking at this as if it's on a dome, your perspective, like, for instance, I'm going to use a low tech version. So you're seeing these words, right? As if you're facing them head on. But then if you're looking at them from an angle, you can clearly see that the words, even though we know that they're the same, they show up differently because your perspective is now changed. Your line of sight has changed. So the line of sight for people on one part of the earth is not going to match the line of sight of others when they're seeing the sun, the moon, and the stars. So either the positions of the sun and the moon and the stars should vary, or the shape of the sun and the moon should vary. In addition, when you get to speaking about optical distortions, you have a problem because the stars themselves should be appearing distorted, and that distortion should match whatever effect that you're saying. So even though we could say stars are points of light from a flat Earth perspective, the distortion of those points of light should be apparent, and they should match whatever flat Earth explanation is used to, explain what we're seeing for the other effects of, circumpolar, stars with two axes, the sun and the moon being the shape and the size that they are from different points of view all over the world being essentially identical, and so forth. And then with the lunar eclipse, why does the leading limb of the moon always face the sun? If the moon's light, if the moon itself is not reflection of the sun's light, why does the moon just so happen to always illuminate as if it's in a position relative to the sun about 300,000 miles or kilometers away from us, with the sun being on average about 93 million miles? Why does that calculation always work as far as positioning the moon as a sphere, reflecting a portion of its surface from the sun to us? And the only variation you can see is a very slight variation from one side of the earth to the other. And the fact that when you're seeing such a panoramic view, the limb of the moon is slightly, off, I guess the path of the leading edge of that moon's, the leading edge of that
About
moon's
30 seconds.
Light, the reflected light headed towards the sun. So it's kind of like this, where it's like, it's kind of going up and away just a little bit, but it's never like the moon is facing this way and the sun is on the other side, or it's not in the same direction. So it's kind of like the whole process of explaining it on the flat Earth side creates more contradictions, and magnetic this and that doesn't justify that.
You got it. Thank you very much for that opening from the globe side. And we're going to kick it over to the flat side. But before we do that, just a couple of quick housekeeping things. In particular, if it's your first time here at Modern Day Debate, we are a neutral debate channel hosting debates on science, religion, and politics. We hope you feel welcome no matter what walk of life you're from. My name is James. I'm your host. And want to say, if you haven't yet, hit that subscribe button, as we have many juicy debates coming up just like this one. For example, at the bottom right of your screen, Aaron Raw and Stewart are going to collide next week on whether or not Christianity is reasonable. You don't want to miss that huge debate, so hit subscribe right now so you don't miss it. And with that, we're going to kick it over to Witsit and Nathan. Thanks so much for being with us. The floor is all yours.
Thank you very much for having us all here. I just wanted to start out by saying that it's a really fun topic, I think, to talk about and to kind of relate to that whole is Christianity rational? How I kind of wanted to open this was with something that I think pretty much every person who is on the flat Earth side was at some point a globe subscriber. We were taught the globe. And I do want to emphasize personally that I do think that for a book like the Bible to be even considered true, the earth has to be flat. If the Bible is considered or even going to be attempted to be the perfect word of God, it has to be accurate when tested scientifically. And the Bible does say that the earth is stationary, is fixed and immovable, and that happens to be what we measure empirically with mechanical gyros. And it is so much so the point empirically that relativity has to say that we cannot do anything from the earth to detect the earth moving. So I think that is something that is for the Bible to be valid, the earth has to match, cosmologically speaking. And so I wanted to say that one of the big questions with this, please, anyone, flat globe, be open-minded to if I can give you any suggestion to what both sides are saying. We have to be rational. It doesn't make any sense to perpetuate something that isn't true, especially when we are dealing with, for example, people in the Gov who are willing to run things like Operation Top Hat. That's our government using a nerve agent on our own military without asking them. So we are dealing with some people who are maybe a little bit nefarious. So I wanted to emphasize that this has very serious ramifications. Either religion could be done away with, or and propel science. Or if the Bible is true, that's really good because Jesus Christ is our Savior, and He gave us a free gift of salvation, set the example for us for how to live and to treat one another with unconditional love, which I think goes a long way. Forgiveness, mercy, and grace. So that said, with the earth itself, I do think that we do have. We'll get to the questions they brought up in the next segment, right?
Yep.
Okay. So just to, is there a way I could share my screen?
Yep, we're ready for you. If you want to drag your cursor over the Zoom window, usually it's at the top or the bottom where it'll have a green button that'll say share screen. It'll have a little upward arrow pointing up.
Okay. And then I just click on screen.
Yep, whichever screen or window you want to share. So there you go.
Okay, so this, okay. So this here is what I wanted to show. So this is basically, first off, with as far as scientifically talking about the Earth, which is what this debate is about. We're talking about the Earth. Matters of the sky are leaving the Earth and going to the sky. So that would be like trying to say if you play baseball with a round ball and a round bat and you round the bases and hit for a rounded average, that the field that you're playing on must also be rounded, which is a false comparison. Whatever the shape of the Earth is that we measure on the ground, we would have to have a sky geometry to match that, but you can't accurately match the sky if the shape of the ground that you're on is incorrect. That said, I personally, well, I'll get into that, but as far as the Earth is concerned, so mechanical gyros do not move, but this here, what you're looking at, this is a picture of 4 lights that were set up over a frozen lake. They are at 5, 6, 7, and 8 miles apart, and according to the curvature, how long have I been going?
You've got 5 minutes and 46 seconds left.
Okay. Austin, can I just finish this real quick and I'll let you?
Yeah.
Okay. So this is 5, 6, 7, 8 miles according to the curvature of the globe claims to know the size of the Earth, which means that we can do calculations to determine how much curvature there should be. This is from an observer height of 6 inches, and you can see all of these lights in a line, planar geometry of the surface of water with depth. This is a span of 5, 6, 7, and 8 miles away from the observer, and this is in on a frozen lake. Actually, if I go to, I think it's right here. This is refraction, the index of refraction, and I can't highlight it through here, but where my cursor is, here you can see it talks about standard temperature is at 20 degrees Celsius. Whatever you measure for your refractive index, if you are in cold weather, you subtract 0.0004 from your measured refractive index. And if you're in warm weather or above 20, you add 0.004. So this is essentially saying that you have light that bends in 2 different directions. You're either going to subtract, making it bend down less, or add, making it bend up, but bend the other way because you're adding 2 different values. You cannot go in 2 different directions and get to the same point. You're going to go in opposite directions. So we see too far in cold weather and in hot weather. With that said, I think that's about all I wanted to get for the beginning. I And here's the whole non-motion thing. You can't tell, relatively speaking, from the Earth. Are you moving? Are you not moving? Which train is moving? This person sees this one. This person would see this one. All right, Austin, I'll pass it to you.
Cool, James. What's left?
Got 3 minutes and 48 seconds.
All right, cool. All right, so basic misunderstandings of the star rotations doesn't prove a globe. A fundamental thing everyone should understand is the entire globe model was engineered based on the sky. Literally, that's how we engineered the globe model. Was we looked at the sky, looked at the stars, looked at the sun, looked at the moon. We came up with stories. We engineered the globe Earth as a theoretical model. We then took the data from the flat Earth or flat map, different flat maps, and put it on a globe. That's what objectively happened. So if you now in 2023 point to the sky and say, look, the sky matches my globe model, that proves my globe model, that's incredibly ignorant because that's how we made the globe model. Okay, now you can show that the star trails work in many different ways. Actually, Walter Bislin, an anti-flat earther, made an entire program showing how you could see it, then just claimed it was impossible because light wouldn't behave that way, in his opinion. Okay, so you can actually watch it diagram out the entire southern star trails, every single observation, declination, inclination, everything about the stars completely mapped out on a plane Earth. You can also put a dome over top of concentric circles and get the exact type of rotation in the south. Basically, what it comes down to is the globe Earth is making a claim antithetical to empirical evidence, right? Like when we do all engineering projects, railways, bridges, long factories, 100 square miles. We use plane survey, which treats the Earth as flat and neglects any type of curvature. And that's how we do all engineering projects in the real practical world. And when we do anything technologically, we assume the Earth's not moving and we build it over top of a plane. So if all physical empirical measurements show that, you have to make calculative assumptions based on optics and then look at the sky, reify the model and reverse engineer it and somehow claim that it's a prediction. That isn't proof of anything. So we need actual substantial empirical evidence void of fallacious reasoning. And I've never actually seen that occur. So hopefully tonight we won't have a bunch of like fallacies and begging the questions, reification fallacies, shifting the burden of proof. Fundamentally, it's said that, oh, well, since you're challenging the popular belief, you have the burden of proof. But that's incorrect, actually. Like you can say that, but the empirical evidence shows one thing. You're claiming the antithesis of that. You have the burden of proof. And flat's not a shape, in case people don't know. So anyway, it's just a description of the surface. I actually think that there's just land coming out of water, but either way, you guys have the burden of proof. Hopefully you'll substantiate that. You won't, though. You'll just say, I don't think this could happen on a flat Earth. We'll have to explain your misunderstandings. And hopefully by the end of it, we'll actually get to where you can substantiate physical demonstration and measurement of curvature and orbital motion. And until then, I guess we'll just sit here with all the empirical evidence.
Thank you very much for that opening as well. We're going to go into the open discussion, but before we do, want to do one other quick housekeeping type thing. In particular, my dear friends, we are absolutely excited as Modern Day Debate is a neutral platform hosting debates so that everybody has their fair shot to make their case, and we want to expand across the internet. We have a huge opportunity. As you can see at the bottom right of your screen, if we hit 1,000 followers on TikTok, we can live stream debates just like this one all the time on TikTok, which is huge in terms of our neutral platform expanding across the web. So if you have a TikTok, I want to encourage you, hit that link at the top of the description box, or I'll pin it at the top of the chat as well, and follow our TikTok, as that will help us unlock that live streaming feature there. With that, thank you very much, gentlemen. The floor is all yours for that open dialogue.
Yeah, there's a couple of things I'd like to address first, just before going into it. I'll address two things, and one is interlinked to another. So first off, for the burden of proof, Witsit is actually making a positive claim. He's making the claim that the Earth is flat. Unfortunately, he stepped into a flat Earth debate today. So he's actually got a burden of proof to demonstrate that the Earth is flat. He doesn't shrug that burden just because he says, hey, I don't have a burden of proof. You're burden shifting. No, he's incorrect. He's making a positive claim. He has a burden. And that ties in with all the observational evidence he claims to say with Nathan's thing of, well, mechanical gyros don't show rotation of the Earth. Yes, but the more accurate ring laser gyroscopes do, thanks to, Bob, who showed it working. Thanks, Bob. And the Foucault pendulum, which actually shows the rotation of the Earth. It's these observational things that we see that shows that Earth is a globe and rotating. So that whole thing about observation and sort of the assumption that, hey, because they calculate for simplicity on a flat plane, and it's only for simplicity, by the way, it must be flat, it's a non sequitur. It doesn't follow. Just because they're doing something for simplicity doesn't mean that is actually the case.
All right, let me address this here, because this seems to be something that you guys frequently misunderstand. So, sure, if I say the Earth is flat, that is a positive claim. I have the burden of proof to substantiate a description of the surface being horizontal, and that level's horizontal. They don't do it for convenience purposes. If I build a 10-mile bridge, right, that would be 70 feet difference on a level horizontal in a curved Earth. Well, we build it horizontal. Guess what, Mark? It works every time. And guess what, Mark?
Yeah, they account for that.
Wait. We can't do it if we don't assume. Whoa. We can't do it if we don't assume it's horizontal. Let me explain the shift in the burden of proof, commonly misunderstood. Shift in the burden of proof, a special case of argument ad ignoranum, is the fallacy of putting the burden of proof on the person who denies or questions the assertion being made. The source of the fallacy is the assumption that something is true unless proven otherwise. Okay, that's a definition of shifting the burden of proof. You guys claim the Earth is a ball that spins, tilted, wobbling, revolving around the sun in a vacuum in an ever-expanding universe of nothingness that came from nothing. That's your claim. I claim a description of the surface. I have physical empirical measurements, millions of them. Plane survey data shows that. Sea level shows that. Okay, so I have substantiated that we measure the surface of the Earth to be flat. You make calculative optical assumptions, putting the plane surveys together, and then you shift the burden of proof. So you need to substantiate your burden of proof that the Earth is a ball that's orbiting around the sun in a vacuum. That if you say that we only need to talk about flat Earth, it is a textbook shift in the burden of proof. I am denying or questioning your assertion being made.
No, you also have an assertion. You're asserting that it's flat, and that is your burden of proof, sir. You cannot shrug that just because you're saying, hey, what we observe, because what we observe is tons of photos, tons of observations. There's all kinds of evidence for the globe Earth. And the whole idea that the universe came from nothing is a straw man, like you usually do your fallacies, Witsit. I mean, if you would just learn fallacies, that would be great. But just because one person claims that the Earth is flat doesn't mean that they just shrug their burden of proof automatically. As far as your bridge thing, the Verrazano Narrow Bridge in New York, even though when it was built, its two suspension towers are 693 feet tall, 4,260 feet apart. Each tower is vertical and perpendicular to the water. They are 42.28 millimeters further apart at the top than the bottom. So you're wrong. They do account for curvature of the Earth when building these things, and you would know that if you knew anything about civil engineering.
Okay, so I'm just going to address this again, then I'm going to let Nathan jump in because I'm on here all the time. You don't, again, I didn't shrug it off. You blatantly misrepresented me.
Joy did.
Why are you being so impulsive? Calm down, man. So I just know, bro, calm down, man.
You claim the Earth is flat. You claim the Earth is flat.
About a minute or two.
You triggered
that has a burden
and
of
then I
proof.
promise we'll come
Calm
right
down,
back
man.
to Mark.
Yeah, like you said, I shrugged it off. I specifically addressed my positive claim. I addressed the evidence for it. You then brought up something about a few millimeters with the bridge. What about Lake Pontchartrain, which is the longest bridge in the world, 24 miles? Let's talk about that. Let's talk about how I talked about 10 miles and 70 feet. You talked about New York and a few millimeters. Okay, we build a horizontal level bridge. We have to treat it as horizontal using plane survey data, which ignores the curvature of the Earth. We build the bridge level, which means horizontal. If we build it level, ignoring curvature, then that's what? Horizontal. Okay, so we build the bridges horizontal. That's how it works. Now you're making a claim that the Earth's not only curving, but that it's tilted, wobbling, spinning, revolving in a vacuum. You have the burden of proof, and we're denying or questioning it. I fulfill my burden of proof. I would love for you to do the same, please.
Hey, Mark, if I could step in.
Yeah,
So,
sure.
Witsit, unfortunately for you, you have just stated a falsehood. So all of this talk that you make about a burden of proof and logical fallacies, one thing that you ignore is false statements. So let's address one of your false statements. You speak about the fact that certain buildings that are built, they're horizontal. Okay, that's great. They're horizontal in that local space, but all of the buildings throughout the Earth are not parallel to each other, vertically speaking. And you have nothing to substantiate otherwise. Secondarily, you did shrug it off. For instance, with the Pontchartrain Bridge, we can look at pictures of that thing all day. You zoom in from a very far distance, and you're seeing the curvature, and you're seeing that curvature, for the most part, following a scale that is consistent with an Earth that is 24,000 miles in circumference. And so all of this discussion about burdens of proof and logical fallacies is kind of irrelevant when you have to look at consistency, accuracy, and reproducibility of the basis that are objectively factual. Okay, the Bible does not address objective fact when it comes to what we observe. It interprets what we observe. For instance, the Hebrews not having access to scientific instruments would use the word above to describe things that are beyond.
Gish galloping, dude.
No.
No, he's not. He's addressing.
This is the definition of gish galloping.
But you're
he's addressing your points, Witsit.
Right, and you're applying
Let's give him another
that
30
definition
seconds.
improperly. Yeah, you're addressing that improperly because you actually did gish gallop, and you gish gallop frequently as almost like an end, like a buttoning up of your argument. You'll go through 4 or 5 points without giving the other people time to respond. That's the definition of gish galloping. So with my 10 seconds left, I yield.
Okay, so Nathan, go ahead. So you can't address the bridge. It's okay.
Okay. So like with the Pontchartrain Bridge, we do get sometimes these pictures that are taken where you do see what appears to be curve. You can get bottom-up disappearance as well. Some of these curvature pictures would actually make the Earth really small, especially compared to the given 24,901 mile equatorial circumference. But then if you go back to the if you go to this 1 second here, if you go to the that 4 lights experiment that I showed, so when a lot of these like bottom-up disappearance and curvature claims, this is something hiding behind curvature. Flat Earth has been able to recreate bottom-up disappearance on a flat surface using isolated variables. And this is done with like temperature variation. This can hide things that are low to the ground. So now that is something that we observe, and then we set up a scaled experiment with isolated variables. I think one thing about like using the words like burden of proof, science doesn't prove anything. We form hypotheses and then we test them. We try to recreate them. We have to isolate our controlled variables, our independent and dependent variables. And when you are, so that the flat Earth for these curvature claims or bottom-up disappearance, we've been able to show how on a flat surface, you can, using things that we get in the atmosphere, like temperature variation, you can actually get this bottom-up disappearance. Now what a globe would have to do, because a globe will say, this is curvature, flat Earth has to recreate on a flat surface, and flat Earth has done that. What the globe needs to do is take that 4 lights experiment, and they need to recreate on a curved surface, because I'm skeptical that refraction can make linear spaced lights have exponential refractive value that scales everything to look and appear exactly planar. So I would need to see a curved surface appearing exactly linear.
Okay.
And then as far as I can just address
Give you one last
quick
point, and then we'll kick it back over to the globe side.
I was just going to kind of get at some of those openings that Mark had provided, but I think I can leave it at that for now.
Okay, well, I'm so glad that Witsit brought up Lake Pontchartrain. I would like to share my screen to show everybody this, if you could be so kind. Okay, so that's the Lake Pontchartrain power lines, just a snapshot of them. The funny thing is with this one, they also did multiple different angles showing the curvature of the Earth as well. So, whoops, sorry, Witsit, you've got a bit of a problem there, buddy. Here's also the Lake Pontchartrain Bridge. Oh no, whoops, Witsit.
That's crazy. So, the Earth is changing sizes, bro.
No, that's not sizes.
It's
just difference in perspective.
So perspective makes it look more or less.
So you're actually, excuse me, Witsit, I'm talking right now, buddy. Cheers, mate. So you're actually referencing something that directly shows that you're 100% wrong, which is just incredible. I mean, the bravery of this man is it's incredible. So the whole
is this like a 4 minute each time type of debate, or was this?
I do want to. I mean, you didn't like me
It's-
interrupting
I do
before, but
want to give
apparently
each
you'll
guy
do it
like maybe a
just
couple
fine.
points
That's
at a time.
interesting, Witsit.
If
They're
you,
making
Why do
like
you think
5 points
that's
at a
fair?
time.
Hold
We're,
on,
we're
he's
never
made-
gonna
he's
hold
made
on,
2
gentlemen,
points.
gentlemen. If you
So
guys
have
would
you,
like, hold on,
Witsit.
Mark, for crying. Okay, so if you guys would like, we can change into like fewer points, but
Sure.
for now, I want to give like a few points each for each side. But let me know. I mean, is that your guys' preference? Because we can
Listen to what they're
change it
doing,
to,
James,
like-
right? They're taking a couple personal jabs at me to start their point, and then they're saying 5 or 6 points, and they're never addressing like the actual points made from us. So
What's
nothing's
personal?
happening.
That's false.
So
Personal.
He's
what
made
what
2
I want
points.
to do is what we'll do
What's
is I think
personal?
remind me who got us started on the open discussion.
I started the open
Mark.
discussion.
Okay.
Yes.
Yep.
So what we'll do is
Right.
we'll give Mark a chance to finish up his speech that he's on, which is about 2 minutes. Then we'll give you roughly the same amount of time with it, and then we'll kick it into like a 1 minute interval thing. Does that make sense?
Okay. Yeah. I mean, we can do whatever. I'm just being honest and realistic, and I know that none of the points are being addressed right now. So it's whatever.
Hey James,
mean?
the thing
So
is he's
let me
not
get-
being honest. So that's the part.
Let
that's
me
annoying.
get this
There's the
straight.
15th
We're-
ad hom. You guys are crushing.
We're addressing. No, he's talking. What are you talking about? We're addressing the points that you're making, but somehow we're making too many points, but we're not addressing them. This is. I can't even believe you said that, Witsit. I've made no personal attacks whatsoever. Everything I've said has been about your arguments, not about you personally. Nothing is about you personally.
Okay.
So I don't know where you're getting that from. It must be sort of a victim complex or something. I don't know what you're.
There's
talking
another
about.
ad hom.
Well, Witsit, it's okay.
Sure.
You're gonna get a few of them. You're gonna get a few of them.
He literally said,
I
"I don't
just-
see any ad homs." Ad hom.
No, but maybe you're
Yeah,
perceiving
I-
it that way. He's pointing out
Maybe
accurately
you are.
your dishonesty, and that's just the way it is.
Yeah, so the thing is,
Let's all
Nathan,
laugh about
if you want to show how everybody's wrong in science about the way that your experiment is working there, what you would do is you would present your experiment for scientists to do under controlled conditions. You would basically write it up in a report and publish it. Take it to people and say, hey, this is what I found about your science that is wrong. And there's nothing stopping you from doing that.
I have been talking. This is separate for what I'm in school for. Currently, right now, is nutrition. Heart disease, by the way, leading cause of death in our country is reversible and preventable with plant-based eating. I have an angiogram proof of that. And so, getting like to write a paper, I was talking to my biology professor, and she actually said that you have to become degreed. You have to then work in the field. Become like a research scientist. It's not anyone that can just pose a paper and then have it get peer reviewed, because we have made long range observations in various conditions with various things, using lasers, using mirrors, using sources of light. We've made these observations in several areas, several locations, from different altitude, different observer heights, especially that one that's under a foot. And then you take into account refraction and having it in various degrees, which sends the light in other directions. And if I could actually to go with, can I share my screen for a sec? So with the gyro here, I think, is everyone seeing this like military video? So this was the military using a mechanical gyro. I think from in the 50s. They're talking about how over time, over 6 hours, the orientation of the axis of the gyro would shift because it's following the Earth. And so then this is a 6 hour sped up video of the gyro, which doesn't do what our own military is saying that would happen with a precise gyro. And so this is actually a mechanical gyro. And I say mechanical because mechanical has to do with its own properties, its own what the constituent parts are subject to forces, physical forces only. Something like a ring laser gyro, the flat Earth would explain that using ether. Light is what is affected by the ether, and so using light. Like this, even Albert Einstein in that quote where he talks about that we can't detect the motion of the Earth, but we know the Earth goes around the sun. He is saying that you can't use anything optical. Nothing with light can show, because all that is detected is the rotation of the ether, the 15 degrees per hour flat Earth would, especially because in science you have to, if Bob was wrong about that, where he was initially at, he can then reform his hypothesis and say, okay, the ether can cause it, and that's what science is about. It's about refining. You can be wrong in science. Science is wrong often.
Okay, is it possible for someone else to step in now? It's been way more than 2 minutes. It's been a lot of time. I'm usually like an agitator, but yeah.
Minute intervals. So if you want to wrap up this point, Nathan, maybe in about 30 seconds, and then we'll jump into those 1 minute intervals that Austin requested.
Yeah, and then the last thing I was gonna do with this video here is actually, this was someone who had gone and with the motion of the Earth and using physical or mechanical things. This was a gyro that didn't move over 4 hours, so much so that they actually this science center actually ended up taking this display down. I think I have it on here somewhere. But they ended up taking this down because it didn't move. When you take the motor out and everything, these things don't always, and sometimes they can go in other directions. But these are things that are not showing motion. So
all right,
okay,
all right. So first of all, you've shown examples, demonstrations that are not experiments.
Timer set.
Yep. So you've shown examples and demonstrations that show that the way that those examples were used were faulty. There's no way to verify the quality of how that experiment was done. So they are rejected. You have nothing to follow up with. Those are what you guys call the black swan, your black swan exceptions to a rule. An exception to a rule, especially when it's not substantiated by an experiment, does not bolster your claim. In addition, when you're being so skeptical, you should validate your skepticism with these facts. And you're not doing that. You're simply declaring things. You're saying, oh, hey, we did this, we did this, we did this, we did that. And here's an example, which is not an experiment, it's a demonstration. So that's not even close. Like, I acknowledge Mark's quality when he presented what he presented, something that, is, you can reproduce that. He showed the Earth in various perspectives. And you guys are showing photographs of failed demonstrations, not even experiments.
So I think that demonstrations or experiments, if you set something up like a gyro and you're examining its properties, rigidity in space, precession of the axis, that is an experiment. That is an observation. So it's an observation that now, when you make an observation of something in the natural world, you have to account that in your worldview. And our own military says that the mechanical gyro, because of its properties, will rotate and change its orientation. Its rigidity in space will change over time. And that is not shown. That was one example of a mechanical gyro, but it's been shown many, many times. It gets harder and harder. That's why a platform like this is actually wonderful for the flat Earth, because it's very difficult to get this type of stuff out there. But there are lots of gyros out there that don't move at all.
Well, what's interesting is, David, if I could, what's interesting is that you're using an old gyro back from who knows when, ages ago. It's not a very accurate gyro. If you're looking for accuracy, you will use a ring laser gyroscope. It is way more accurate than what you're displaying there. So basically you're saying, well, I'm going to take the least accurate thing I can and ignore the most accurate thing I can, which it's a 15 degree per hour drift on every single ring laser gyroscope throughout the world without exception. Like, yeah, it will happen. And I want to know from you, and this is a really important question, what is ether? What are the properties of ether? What experimentation did you do to show that ether is an element that exists and has some kind of effect on the world? How do you know that an ether exists?
So I do agree, ring laser gyros, very sensitive, very accurate, and they do really well detect the rotation of the ether, of this medium. The ether is a medium. It's the field that light is allowed to propagate through, or to travel through, however you want to say it, to get the picture there. The ether is, now, can I I'm not gonna beat around the bush with it. I cannot provide a handful of ether to give you. It's not something that currently we have the time or the technology to do. And this, I don't know fallacies that well, but like what is dark matter, dark energy? Can I have a piece of space-time fabric? There are things that we use to explain, but I think that the ether, people like Tesla and Heaviside and these people were using the ideas of the ether, the predictions you're allowed to make, and they set up our electricity, the way that we have our our field theory and everything is based off of the ether.
So, Nathan, it's strange how your alternative explanations just so happen to follow a 24-hour rotation of something that is the equivalent of 24,000 miles in circumference. Your explanation of why gyros work or why the stars move the way they do, why all these things happen, they all seem to align with something that would just so happen to be a 24,000-mile spherical surface with a 24-hour rotation. What a strange coincidence. It's like Occam's razor, but in reverse.
So actually, a rotating globe would show motion to a ring laser gyro and a mechanical gyro. A flat Earth can account for a non-rotating mechanical gyro and a rotating ring laser gyro, which is what we observe.
I don't think so.
You won't address that?
Nah, that's not. You're making that up. So
no,
it's observed.
Nuh-uh.
When has ether been observed?
Can I say something now? Hey, can I say something now? Is that okay? Hey, so we're gonna go back to the beginning. You guys wanted to run away. You did it on purpose. Mark pretended that he won.
Why are you changing the subject?
No, I'm going back to the first subject, which was what you ran away from. You showed a picture of Pontchartrain and pretended it proved me wrong. It didn't. 24 feet. That's almost 400 feet of curvature you'd have to account for. We know that that's not the actual curvature rate, or the Earth would have to be like half the size you claim it is. Secondly, there's a 104-mile bridge in China, right? And it would have thousands, like 7,000 feet of curvature. So you showing a picture and saying, haha, you're stupid, and then sprinting away from letting me rebut it is not somehow you annihilating me. Okay,
why don't you just rebut it?
Wait. And I'm going to
address.
We're going to give Austin
and I'm going to
another 30
address
seconds,
what
and then
you
we'll
just
go
said.
back.
And I'm going to address what you just said, which is actually we have a sidereal rotation that is measured with the stars. That's where we get the 24-hour days. We actually 24 hours and 23 hours and 56 minutes. That's literally where we got the construct of time. For you to pretend that somehow what a coincidence it matches, that's where we got the sidereal rotation. The sky moves. You claim it looks like it moves, but the Earth moves. And it translates centrifugal force. If you understood the theory of relativity, you would understand that it actually says that on a stationary Earth, it would translate centrifugal force to the Earth, which of course we don't believe in relativity anyway. So there you go. You just have a fundamental misunderstanding, and all of quantum physics knows there's now an ether. So you guys will just have to crawl back over here anyway.
So you
so
1 minute
means anything.
Contradicted you in the first place.
Yeah, none of this means anything. This is just word salad from Witsit. He's basically appealing now to relativity, which he doesn't believe in. There's no 400-mile bridge in China. Which
I said 100 mile.
I thought you said a 400.
You might want to slow down your rate of speed, Witsit. You're talking too fast.
Yeah, so
not heard
all of that is just word salad and hand waving. So we provide photos, we provide sort of demonstrations, we provide all of this. Witsit, could you just stop stroking your ego for 2 seconds?
Hand wave dismiss everything.
Hold on. All right,
so we showed the pictures, we showed all of the evidence. We're basically talking about ether in a sort of, rush out stage left. Witsit goes back to, actually my bridge thing, even though it shows that he's wrong in plain, sort of straight in front of your eyes, he wants to go back to that and say, well, no, actually, don't believe your eyes. Actually, all of this word salad, for some reason, it doesn't apply. No, it does apply. There's nothing that Witsit has said here that has any validation, but I would like to go back to ether because we were discussing that. And what proof do you have for this magical ether, Witsit? What experiments have you done? What studies show that this stuff actually exists? If you can't show it to me, if you can't demonstrate it, if you can't present anything about it, why should anybody believe that this magical substance actually exists?
Why don't you apply the same criticism to your own belief system about the theory of relativity? But again, Actually, if we just look at our eyes, if we just take our eyes and believe our eyes, the Earth would be flat, right? The horizon's horizontal, and we see the stars move. Oh, all of a sudden we do believe our eyes. And we look at Lake Pontchartrain, which changes curvature rate. Admittedly, if that was the actual curvature rate, it would make the Earth way smaller. You ignored that point. Secondly, when they actually did the engineering blueprints for Lake Pontchartrain, they used plane survey data. Thanks for playing. Same thing in China. Plane survey data. That's 7,000 feet horizontal level in small increments that they would have to account for. They didn't account for. They built all the bridges like it was a plane. You're throwing away the engineering and the physical building and the physical level, not accounting for curvature means horizontal. You ignore that point. Then you said word salad. I bet you couldn't even define word salad. Word salad is something like wall, 7, chicken, yesterday. Literally incoherent words that make no sense. Nothing I said was word salad. And fifthly, there's unified field theories being proposed to explain the unification of the forces, theory of everything, the grand unified theory, all explaining a background medium, which is required because we have the Casimir effect, right? Which we have non-conductive plates that show energy fluctuations within a vacuum. We have vacuum energy, 0-point energy, quantum foam, quantum energy, all these different claims they give to the fact that we know there's something outside of the vacuum, and the vacuum is not just Newtonian emptiness. And that this is well known. I can cite many Nobel Prize winning physicists within the top levels of quantum mechanics. There is 100% a background. Frank Wilczek, 2008, said that there must in fact be an ether. The fatherhead of quantum mechanics.
You can make your own.
The father of quantum mechanics, Paul Dirac, said that
we are rather. To wrap up this point, Witsit, and then we'll kick it back over to the other.
The father of quantum mechanics, Paul Dirac, said we are rather forced to have an ether because the velocity must be of a real physical thing. Frank Wilczek said that we're entering a new golden age of physics. There must in fact be an all-encompassing substance of everything that holds it together, also known as an ether. And I could go on and on and on. Robert Laughlin from Stanford.
Wrapping up.
Whatever.
Go ahead,
See, I have to do this because this is how that now we're maximizing sophistry. That's why. So I have to speed through a minute.
Still wrapping up.
That's what you get.
Still going, is he?
Yeah. Okay. So look. So, Witsit. Well, actually, both of you. So you just did it again. You're reciting. You're doing what's called gish galloping, and your rate of speed of speech. It's like a substitute for content, for the quality of your content. So we're back to a contradiction. You said on one hand, hey, trust your senses. But then on the other hand, don't trust your senses. And so one thing that you do with Witsit that is quite, it used to be annoying, but now I'm entertained. I look at my little imaginary watch here and wait to see when you do it. You're arbitrary. You bring up points that have arbitrary relevance. They're not directly related, or they may be directly related, but you think that talking about relativity is going to determine how this argument turns out. And the fact of the matter is it doesn't. The Pontchartrain Bridge, and also to you, Nathan, the Pontchartrain Bridge may show some distortion on that rate of curvature, but you got to keep in mind, you're zooming in to see that bridge over a millimeter of viewable angle on the horizon where there's so much distortion. And you guys are trying to explain that, all of this refraction, the refractive indices on the horizon is somehow explainable on the Earth. And here's something you overlook, Nate. When you have a refractive index that's caused by those temperature variations, you would have a concave result on a flat plane. That flat plane would appear to be concave as you're looking like a bowl. It would be in every direction. You zoom in, you're seeing that land rise up. And you never, no. You have never demonstrated that, and you can't demonstrate it because it doesn't happen. And you know why it doesn't happen? Because the Earth is curved. Now I can do it.
So with that Pontchartrain Bridge, in the images that were shown, you can see that there is some the bridge is essentially, it looks like it's floating, and I don't think that bridge is actually floating. So there are some optical things going on, but we have shown on a flat surface, we've shown things that cause this type of miraging. I think it's called phantom organa, or there are a few different types of optical things that we can see over water. But the flat Earth has been able to recreate these using isolated variables,
not at those distances,
like temperature.
Let him finish, David.
Yeah, so sorry. With what I had asked for with the four lights experiment, I would like to see a curved surface that appears to yield results that are exactly flat. You mentioned a bowl, but if the Earth is curved, and we see exactly flat. I want to see a curved surface appear exactly flat, isolating a variable of refraction that is to scale, because linear space lights that are going over exponential curve seems like it would be pretty difficult for light to get that exactly flat, and we never see it bowl shaped. It's always, there's either bottom up disappearance, which has been shown on a flat surface. There is also or it just appears flat, which is nature would really be trying to do something by just appearing flat any other time that it's not bottom up disappearance, which is shown on a flat surface. And then as far as the ether, it's a background, and we don't, it could just, you could call it a frontier, but it is kind of similar to space-time fabric, which is like a four-dimensional, three-dimensional. We can't even be shown four-dimensional object. We only get three-dimensional recreations. So I mean,
wrap it up?
That's kind of what I'll say for that. And then I would be happy to, Mark, if you'd like, go over some of the things that you had talked about in your opener, whenever,
Sure.
But just wherever y'all would, yeah.
Go ahead, Mark.
I'd love to go
Is
over in
that
this one.
good,
but,
David?
I'd like to
No,
address
it's Mark's
sort of
turn. I
Witsit.
want to let him.
Yeah. I'd just like to address Witsit's Gish Gallop for a moment, because I did note all this down. You're sort of saying that theory of relativity, we've never done experiments. Of course we have. We've done atomic clocks. There's been testable predictions like Venus and things like that. The precession of Mercury and things like that. There has been testable predictions made. There has been experiments done. So you're basically saying, well, field theory and going into quantum physics. No quantum physicist is saying that because of quantum foam, the Earth is flat. That is not what they say, and they don't call it ether, and they don't say the effect of quantum foam is somehow making all of these things that make it seem like the Earth is a globe for some reason be flat. So you are just misrepresenting people as usual, basically saying this physicist has said there's quantum foam, therefore Earth flat, ether exists. That is not what they're saying in the slightest, and you know it, Witsit. That is absolutely reprehensible. The whole idea of the golden age of physics, you know, there's going to be this new thing that we're suddenly going to find ether. No, nobody is saying that there's an ether which makes it look like the Earth curves when it's flat all of a sudden. Nobody is saying that, and to say so is a gross misrepresentation of people's work, because you toss out all these names, but they don't believe the Earth is flat. They think it's round. The quantum foam doesn't cause this. And I really would like you to address, instead of just hand-waving circumpolar stars away, to actually address what I've been saying rather than just sort of hand-waving it away and saying we don't understand how it works.
We're actually going to address your straw man fallacy. I'm going to address this straw man fallacy. So I never said that because there's quantum foam, it means the Earth is flat. What a remedial straw man fallacy. So you said you wanted evidence for the ether, clinging on to a desperate attempt to get away from the fact that we engineer using horizontal survey. And so I explained to you, yeah, there's tons of evidence that there's an ether. Tons of evidence. I began to go into detail about the evidence for the ether. You then grossly misrepresented and strawmanned it as if I said, these people think the Earth's flat, which is an all or nothing fallacy. You don't have to believe everything that someone says, or you can't invoke them. That's also remedial. You strawman me to claim that the ether somehow means that the Earth is flat. Strawman fallacy. Nothing to do with that. And it's an equivocation fallacy. It's a non sequitur. It's a red herring fallacy. Everything you do is a fallacy. And then we're going to go back to where you just claimed relativity works perfectly, which is hilarious. You actually brought up the precession of Mercury, which is actually called perihelion. It has a perihelion shift, which is referred to in astronomy as the Mercury anomaly. So Newtonian was off by 43 degrees. Einsteinian didn't work. They had to use something called the Schwarzschild equation, which assumes a massless path and actually utilizes imaginary numbers for equations 7 and 8, both in the same base. So it has to assume a massless path even to get the math to work, and it still doesn't work. It's still called Mercury's anomaly, and then it's actually been proposed many different, like the Kerr metric, etc., saying, oh, it must be the sun's actually a black hole, but it must be spinning faster than it really is, and it has to be more charged than it really is. To explain the Mercury anomaly, the fact you brought up the precession, so you just read Google, actually it's known that general relativity doesn't explain the precession. General relativity is just an idea. It doesn't work on the quantum scale at all, and whatever the true explanation is, has to work on all scales, because the quantum scale makes up all the big scales. So please stop straw manning me and ad homing me, and that would be great if you guys could just calm down with all the
Actually,
gaslighting.
Einstein
What is the
predicted it, so you don't
procession
know anything. Einstein predicted it.
It was observed 60 years before him.
It was predicted. No, it was predicted. You're wrong.
It was observed 60 years before
wrong.
him.
You are 100% wrong. He predicted it.
It was observed 60
Sorry,
years before
Witsit,
that.
you're wrong. I'm sorry.
Okay, when what you want to bet on it? When was the
We're not
perihelion
talking about
shift
the shape of the
Mercury
Earth.
observed?
Ice-
When was the
ice-
Yeah,
perihelion
yeah.
shift of
Witsit's
Mercury
gone
observed?
from the shape of the Earth. He's off on a tangent. He's
Wait,
off
when
somewhere in
was
the
the
bush saying, you know. Sorry,
Hey,
could
not
you
bad,
give me
Witsit.
some?
No, we don't get
Show me some
no.
evidence.
I
When
do
was the
want
perihelion-
to I do want to kick it over. We'll give it 1 minute for Mark, and then we'll come back.
Okay, so notice he didn't actually touch the stars with a 10-foot barge pole. He just didn't go there. Didn't want to go there. Just wants to bring up something incidental. And Einstein did predict the precession of Mercury, but Witsit just wants to go anywhere but the Earth. He's off into the rest of the universe. So And I mean, he doesn't even believe that Mercury's there anyway. Like, let's face it. He's deep in the
light in the
Bible and
sky
just
with it,
believing
isn't it?
that the Bible is just, it's just the Earth and it's
All
just the light
personal
in the
insults,
sky.
James. Is this why I'm here? All personal insults?
So what?
That's not a person. Is
Austin,
your
can I
worldview?
I don't
based
have
in
to
the
be here, by
Bible?
the way. Like, how about you pretend to be able to debate?
The Bible was brought up, Witsit. It was brought up
Yeah.
as a point. So don't go there because it was brought up as a point by Nathan. So
We'll let the
deal
audience
with that in
decide. They
some
know
way.
you're doing nothing but attacking me. Okay.
Mark, I will.
Or
So
Witsit.
I do think
Yeah.
that the with the stars, so you do have star trails. Austin was talking about the ether because that was something that you had asked, but going to the stars for
Sure,
your opener,
sure.
I think, is more leaving the Earth than talking about the shape of the Earth or the motion of the ground or the shape of the ground or water. There actually was, though, as far as land goes, someone did, I think it was like 30 some kilometers, 26 miles over land in Canada, and they could see the source of the laser, which would be even less refraction because it's not over water. You can check. I think Taboo Conspiracy has it on his channel, and I think I have the guy's channel as well, which I can share. But as far as the star trails go, so one of the big differences that I think people should really think through is the flat Earth does not claim to know the stars. Now, if you burp on an exoplanet, the globe is going to say we can detect what the gases are or that are in the atmosphere, and so you can tell what is going on on another planet. So there's a lot of extra claim to knowledge in a globe Earth. But as far as how the stars go, we can't really we don't have a model quite per se for the stars. But if you do, like if you were standing in a tunnel and you were in the middle with in between two ends and you're standing here, if you look towards one end and you take like a laser pointer, you can spin it right above you and go east to west and get straight lines like you had shown. And then as you follow those lines, the tunnel is going to start to focus in. So you're going to get narrower and narrower as you go towards one entrance or towards the other. And you can always keep that east to west. I'll be able to demonstrate it.
Mark, can I jump
another
in?
time?
Sure.
I haven't gone to a tunnel to do this, but visually I know what it'll show.
So Nate, can I? It's been a couple minutes. Okay, so here's the thing. I spoke about the concavity, the bowl effect. So here's the thing. I want you to think about this logically. The Earth is flat as far as you're concerned, and a laser can be pointed from one part of the Earth to the other. All right, that will be a demonstration of a flat Earth with no refraction, no refractive index, way out yonder, because the laser would be doing what it should be doing over a flat Earth. Right?
The Earth doesn't have no refraction, though.
I'm not saying that the Earth has refraction. I'm talking about the air above the Earth. There's no refractive index. That the refraction is caused by a fluid.
Air is a fluid.
Right.
Air, any transparent.
I'm sorry. Also, anything that's solid and transparent. That's true. Right. But in this discussion, we're speaking of fluids like air and maybe water. The point is, Right, but it's still a fluid. A gas is also known as
Yes.
a fluid. So
Okay.
in any event, you're looking at something without a refractive index that will show you that laser from one part of the Earth to the other.
Can
Right.
I ask something just for clarification? I just want to know I'm following along with your example here. So you're saying if you shine a laser on an Earth, I just want to clarify. So you're saying if you shine a laser where there's no refraction, you can see it far away on a flat Earth?
I'm trying to verify with you that would be the case on a flat Earth. You're on a flat Earth and you're pointing a laser along this flat plane of existence from the source to the observer, and you see it. You see it 26 miles away. A demonstration for you that the Earth is indeed flat, right?
Yes.
Okay. Now, watch
But there
this.
is it's not a vacuum.
I don't care if there's a vacuum. It doesn't matter. You can see the laser. You are making your own argument. I'm just affirming your argument. So there's a problem here. What happens when you don't see those lasers? From those distances. What would you explain that to be caused by? A refractive effect of some sort? Yes.
It would be an atmosphere effect. Refraction. Both sides do use refraction, but the flat Earth can recreate both sides of it. It's not seeing and seeing. That's why I would like to see the four lights from grow to one.
Yeah, you're kind of distracting.
To see that on the curved surface.
You're distracting what I'm saying, and I know my time is limited. So
no, please explain, because I want to make sure I'm following you.
I'm trying. You've already followed two of the points here, so the third should be easy. If the laser is able to be seen on the flat Earth along a great distance because of no refraction, and the laser cannot be seen along that distance because there is refraction, then you should see that bowl effect that I told you about when there is no laser. Just think, let that marinate.
Why would there be a bowl? Refraction will, if there's a greater refractive index, the light from the source will be bent down and it won't reach the observer.
All of the light would be bent down, not just the laser. That means if I don't see the laser, that means the background in front of me is also affected. The light from the grass, from the dirt, from little hills nearby, that's also going to be bent up because that light is being bent, is curving downward. So things that were down are also being bent up. That's where you would have that bowl effect. On a flat Earth, you would have that bowl effect, but you don't have that bowl effect. It stops
exactly flat.
When there's, you just contradicted yourself.
Nope. When there's no refraction. Did you just say it's
not exactly flat?
What's that?
Did you just say it's not exactly flat?
No, when the Earth is flat, when there's not as much refraction, you see the Earth as its true shape, which is planar. But then when there is an increased amount of refraction, that would cause light to bend down further, because the more refraction, the more light is bent down. That light that is originally coming from the flat source over here is going to be bent down before it reaches this person. When there's minimum refraction, light is able to travel all the way across, to propagate all the way across and reach the observer so that you can actually see the source.
Right, but you're not understanding how the dynamics of that work. You're only thinking about the laser. So the laser has a height, the thing below the laser has a height, the thing above the laser has a height. Your line of sight is essentially, it's almost like from the source, everything is tilted like this. So things that are below are going to run. It's called looming, I think. I think it's called looming. There's looming and sinking. So you're speaking of what's called sinking, but the sinking effect isn't that everything sinks down. It's that the angle of refraction, the angle that the light sources occur are distorted. They're all bending from here downward. So you have stuff that's oriented lower that's shifting towards your line of sight. It's not that everything goes down. See, you don't understand it. And I'm trying to explain it to you in a matter of fact, down to earth way, instead of talking about sine, the change of sine to cosine over this distance and all the other stuff, because it'll just sound like nonsense to you. What I'm trying to get
I know what you're saying, but it's
right.
Both models will use refraction, saying one model will claim there's more refraction causing an observation, but then normal conditions are when there's less, and then the other one will say when there's less refraction, that's the special condition versus more refraction, which is normal condition.
Then you're having a different conversation. I'm speaking about the angle of the refraction. you either have a refraction that causes looming or a refraction that causes sinking. And in all of your arguments, you're only able to speak about the sinking from the point of view of an observer, not from the sense of everything from the source. If you're going to have some sinking, for instance, you'll have boats floating in midair, right? That's over the water, right? Yeah. But in some instances, you'll have mountains and buildings that are higher all the way to the surface, you know. But because you're looking only at water, see, water has this effect of doing this mirroring effect, and it literally looks like it's cutting off, and that's where the floating is. But the boat isn't the only thing that exists out yonder. It's just that it's the only thing that you can see past a certain distance. So if you take objects that are, you know, close to a mountain, close to a city, close to something, then you should see the looming and sinking. You're only speaking of one because you know that on the flat earth, you can't explain the other.
Well, I do agree that is we do see sometimes just boats, but we have also made observations where people will go to the other side of a large body of water, and on the other side, you can see the beach, you can see the light source itself, you can see the buildings, you can see everything. It's not just one object.
But it's not consistent with your demonstration. That's what I'm trying to get across. Though that would be the case if you don't see the laser. You won't see it if you do see the laser. You see what I'm saying? Or vice versa. It's not going to be that you see the laser and you see the effect on a flat earth. That's the problem. Now, the dynamics of it gets so confusing because I'm trying to explain something from the perspective of something that is absurd, and I'm trying to make it sound consistent. All I need to explain to you is that you got to have an explanation for one and the other. And temperature creates the gases expand. So what ends up happening is that the density of the gases decrease, and that is what allows the refraction to occur. So every morning, you got, hot air rising as the the lake, and the fog and all the other stuff goes on. Now, I'm not saying that I know it all like from memory too well, and I'm sure Witsit would come in and make some corrections, which is fine. Witsit, you can correct me when I make mistakes, but Nate, you can't explain what we're seeing. We see the Pontchartrain Bridge; it's always curving, and the few times that it doesn't, matches refractive index, which allows the looming to occur. That means your laser would not be seen.
So sorry, go ahead, Nathan. Sorry, mate. Go.
Do you agree that if say on a flat surface, if we're going to assume that the Earth is that the ground is flat for this assumption that we're trying to make, if you have if you have a light source and the observer on a flat Earth, if you have refraction that bends light down from this light source, light is going to get bent down and you're not going to see it. So that would be what a globe would say, that's hidden behind the curvature.
No.
On a flat, the explanation on a flat Earth would be the bent that the light is being bent down, so that is why we appear to not see it. When there isn't enough refraction to bend the light down and we see the laser, the flat Earth, because both models have to explain. You have to, if we observe something, you have to have an explanation that doesn't contradict other explanations. So the flat Earth explanation for this observation of seeing a light 26 miles away over land by a railroad, when we see it, it's because it's traveling straight. If we don't see it, it's going to be because refraction is such, given the conditions of the day, that it bends down and prevents us from seeing it.
So then
I'd like to just a second, David. Just a sec. I'd like to add height into the equation as well, because on a globe, when you go up, you actually see a lot further, which doesn't make sense on a flat Earth, because there should be nothing obstructing that laser on a flat Earth. It should be perfectly across. However, we know that when you gain in height, and I think a guy called Jeranism proved it, flat Earth has got a fine history of disproving the flat Earth, when he increased in height, you could see the light he was shining, kind of thing. So we know that if it was just a flat, straight plane like your desk, right, it was just absolutely perfectly flat, we should be able to see that laser regardless. But if you go up, because it's a right angle triangle, the hypotenuse is going to be longer than the distance along the bottom, right? It's a longer distance if you increase the verticality, but yet it comes into view rather than being obscured. So the thing is, if what you're saying is true and it's being refracted down, there's no reason on a flat plane why increasing the height should allow you to see it better, because it's still being refracted down.
On a flat Earth, both models make the claim that an increase in elevation is going to increase the amount of ground that you see and skies. Because you have a vanishing point where if you are looking straight, your ground. Say you look straight ahead, and then you just took a picture, and you looked at that 2D picture. The ground is going to appear to go towards the middle, and the sky is going to appear to go towards the middle as well. They're going to converge. And so if you go up, you're going to now push that vanishing line back. You're going to get a little bit more ground information. And
sorry to interrupt, Nathan. We're not talking about the ground. We're talking about a laser, right?
Yes. And that's linear, not exponential. The curve.
You literally said that when you go higher, you can see further.
That's what you said. Both models is what I was addressing there.
Yeah, I know, but Mark said see further, and then you explained why, and then he said, no, we're not talking about that. Oh, but it's like basically these debates need to be two Globers versus one flat earther. Like I wasn't even here. I guarantee you, Nathan just been schooling both of you the whole time.
Well, it's your fault if you weren't here, Witsit.
Right. Don't understand that you would see further as you go higher on a flat earth. That's pretty bad.
And that's I just like that, and like with David, why I was asking you, like I just want to clarify with you, because I think what people really need to be, I assume we're all trying to be open minded, and so I just and for people watching as well, being as thorough as possible. We just want to make sure we're getting our points understood. We want both sides, because we all want to be reporting on correct information and what accurate claims are, right?
Okay.
We just want to make sure we're following along and trying to make sure things are as clear and understood as possible. We all want.
Why don't we go ahead and skip all that? Yeah. So look, I'm going to say
now it's your turn to monologue again about stuff you don't understand.
Thanks, Witsit. So no problem. I'm trying to say to you, Nate, that the thing is, and like I said, because I'm trying to see it from your perspective, I am being open-minded, but I still have a problem with understanding how you look at refractive indexes. And if I have it reversed, I still have a valid argument, because it's got to happen either one way or the other. Either it happens with the refractive index causing the light to bend down and you see concavity, or it happens when the light is bent up and you see concavity. One way or another, you got to have a lot of examples of concavity on your flat Earth model when there is or when there is not a refractive index occurring. You can't explain it. You're trying to hold on to one side, and it must happen on the other side, and you're not able to explain that. And then Witsit comes in and helps you.
Well, Witsit, Austin, do you mind if I take this? So when there is refraction, bends light down, and so when there is not enough refraction in the air, we make the flat Earth confirming observation. I shouldn't say confirming, but for my own purposes, we see what would validate a flat Earth when there is not enough refraction to bend it down. When we don't see it and it appears low below the horizon, it's being bent down.
I'm not sure.
Refractive indices can cause light to bend down and up. Okay. So either you explain it for both, or you don't have a good argument as a flat earther. This is on a flat plane. I'm not showing you a curved Earth. So when does this happen? When does this happen? When does this happen right here? Because you've been spending all our time talking about this. When does that happen?
Why don't you tell us, since you guys claim it's density layers?
No, I'm not a flat earther. I refuse to tell you, because that's not my argument.
It doesn't work.
Because you don't understand anything other than how to regurgitate anti-flat Earth scripts.
Then debunk me. Explain it.
Okay. Yeah. Light does all kinds of things in the atmosphere, and it's not just based on density layers, and that's what you guys claim, is that it bends towards the more dense medium. The fact you just drew a piece of paper with arrows going up debunks your terrestrial refraction claim that you don't understand and reapplies our value. So see, if I talk for 15 seconds, you have to interrupt. Yeah. Right? So that's the truth. This is why you guys are, honestly, you should not be communicated with.
Well, don't
you don't have good faith. So we'll just let Nathan
I didn't
keep
interrupt.
Talking,
so keep going, Witsit.
No, you got it. Nathan talking.
So
They don't
like
have
you
any
had,
good
you had
fit.
given the example about the mountain, right? That it appeared a little bit higher. So that could be refraction being upwards. You also have perspective as well, and apparent size and distance factoring in. But if you see something in the distance higher up, that is an upward
Nate,
refraction
with all due
example.
respect, you keep misunderstanding my argument. I try to explain it. I'm saying the consistency of when it happens has to be consistent with when you see or don't see the laser. That's the problem. Of course, we have instances where you see the mountains looming and sinking. I get that. But your concept of the sinking and looming is not consistent with when you see or don't see the laser. And that would be an experiment that you guys would have
The
done.
laser is seen or down.
That
or
doesn't,
it's
that
either
doesn't
seen or
even
not
sound
seen,
like
right?
a coherent response. It's seen down. What does that even mean, bro?
So if you see the laser source, that you're going to see it, that is the conditions of the atmosphere are so that it reaches your eye. And if you can't see it because you have to, say you're so far back that you can't see it, but then you move closer, that means that it was being bent down. So if you move closer, now you're going to be able to see it. So that's an example. This laser example is light
When do
bending
you
down.
not see it? You see it when you think that the refractive index is so hard that it's causing the laser to not be seen, right?
Certain conditions you won't be able to see. You can see like at a lake with tides, or at a lake. You can see it at a bay with tides. You can see sometimes, like you can see the other side of the bay, and then when there are tides, different refraction changes.
You messed up. Because for you, from your flat Earth perspective, this happens all the time. This would happen all the time, Nate.
Dependent.
No, it's not. It's like 99.8% of the time it happens.
Atmosphere, I mean, weather changes daily, and so the amount of water vapor in the air will change.
It doesn't follow the pattern of the weather changes. You would say then it should follow those weather patterns, and it doesn't. It doesn't, not for a
because
flat
we
Earth.
don't see the laser over those distances, basically.
Right.
So as the weather
Really? Do you
changes,
have
we
the
should-
math and the data to show that your terrestrial refraction with
Do
the
you have
conditions
math and
actually
data to
matches the?
refute it? Burden of proof
Dude,
is on you,
James,
bud.
what the? 7 seconds in, dude.
I think it's true, David. You interrupt an awful
He's
lot. and
cheering
you promised,
about it.
You promised.
I
like a-
Hold on. Would
apologize.
you guys shut up for a second? Even while I'm talking, you interrupt. So, just to be fair to Austin, you did promise, David. You told me that I could tell Austin that you wouldn't interrupt. So I do want to keep. It is pretty lively tonight, and like I said, I like it when you guys have passion, but at the same time, anything can be too much. So go ahead, Austin.
Okay. So if they're claiming terrestrial refraction, which is 7/6R, which is the radius value, which is an agreed upon average of 15%, that's because we see it too far 15% of the time. On average, it's actually 15% further, not 15% of the time. On average, it's 15% too far. So it's just a number, and then we try to account for the variables. So you guys never provide the actual data to show, oh, we saw the laser on this day based on these conditions, and that's why we didn't see the laser on that day based on those conditions. You never do that. Nathan is specifically presenting to you warmer conditions, colder conditions, closer temperature differentials between the surface and the body of water or the ice, and closer temperature differentials. And you guys are just hand-wave dismissing it and then repeating the script over and over. He's showing you that we see the lasers too far in all the conditions, and relative to your terrestrial refraction claim, that doesn't work.
He did
Yeah,
not
there's
do
been
that.
many
He showed a
experiments.
demonstration.
Yeah, there's been many experiments that have shown refraction over water, Witsit, and the refractive index that is applied to them. It's not like scientists have just been twiddling their thumbs not doing these experiments. Of course they've been doing these experiments, and they produce papers on them. You know who doesn't produce papers? Flat earthers. That's who doesn't
Poisoning the
produce
well.
papers. And
Poisoning
yeah,
the
if I
well
could just
fallacy.
stop interrupting, Witsit.
It's true. The
Come on,
door
mate. You
swings
just
both ways.
complained about being interrupted, and then you interrupt me, which is
You've
weird,
been talking for
to be honest
90% of
with
the
you.
debate.
Let's kick it over to Mark. And
What?
To the door. The door swings both ways. So I do. Let's go ahead, Mark, and then we'll kick it back over to.
Are you
Austin and
serious?
Nathan.
Okay, so this is so Witsit's whole thing is like what he basically said before was light does all kinds of things. Now this is the kind of accuracy we expect out of the flat Earth side. He's not going to mention what kinds of things they do. He's not going to actually show that they do these things like any kind of scientific experimentation or anything like that. No, he's just going to say light does all kinds of things, so that basically excuses any anomalous data that we see. Of course, scientists are doing experiments. They produce papers. Look them up, Witsit. It's not that hard. If you want to challenge them, And great, go for it. If you want to challenge them, produce your own papers. You sound like a knowledgeable lad. You can write a paper and do some experimentation on the refraction of light over lakes and basically hand it off to one of the physicists that you always boast about talking to have them review it and see if it's got any merit. But you won't and you don't. And I think that's sort of blatantly obvious for everybody.
Okay, so I'm going to respond now. So everything he said was gaslighting. That's all he has is sophistry. Let me define sophistry for the room here. It is the use of fallacious arguments with the intention of deceiving. That's all that he has. For example, you know who doesn't do experiments and write papers? Flat earthers, poisoning the well. He said that I just said light does all kinds of things. Strawman fallacy. If you think that fallacies don't matter in debate, you don't know what debate is. That invalidates your argument. That's why we have logical fallacies. I actually talked to Thomas Young. We emailed, not me personally, but a flat earther, emailed Thomas Young, which is the subject matter expert for terrestrial refraction from San Diego State. And we specifically talked to him about these specific things. And he said exactly what I just said, that you hand wave dismiss. Hand wave dismissal is also a fallacy, Mark. Everything that you said is a fallacy. Your ad homs, your red herrings, your poisoning the well fallacies, that's all that you got. So let me repeat the point, see if you can specifically rebut it for once, okay? If you want to show the actual data that rebuts Nathan's claim, which is that in all the conditions, we see the laser too far, you claim that it's based on humidity, temperature differential, and density layers, which I'm sure you don't even know, right? And that's how you get terrestrial refraction. You get an average of 7/6R, which is 15% too far. So if you want to explain why, despite there are different temperature differentials, different temperature conditions and humidity conditions, we still see the laser way too far, then you would be rebutting his actual point that he made all the way back in the opener. Not just vaguely claiming science, saying flat earthers do nothing, and gaslighting the opponent the whole time.
Well, I'd like to address that because a lot of claims were put against me right there. A lot of, empty, hollow assertions about sort of straw man, which I didn't do. I read out exactly what you said. I wrote it down. Light does all kinds of things was exactly what you said. That was word for word, so it's not a straw man of your position at all. Thomas Young, being a sort of person involved in optics, I'm not sure which one you're talking about, but if they support that refractive index doesn't support a globe model, that's fine. But I think you're just name dropping and sort of saying, hey, this guy agrees with me when they don't at all, which you're actually famous for doing. I'm sorry, Witsit, that's just the case. So no, there's no fallacies being made here. It's just pointing out mistakes and incorrect positions and fallacies that you're making. So this is what's called an appeal to authority. You're basically saying somebody's name and saying, well, they agree with me, and suggesting they agree with you, which they don't, and none of them do, and you know it.
Okay,
And
so
we
once
all know
again, you just gaslighted again. That's all you're doing.
How did
is
I gaslight?
Why are you interrupting? So you're personally insulting with ad homs. Please keep that to yourself about what I'm famous for doing and all this nonsense. You brought up all the experts. You appealed to them and said, why don't you go talk to them? I rebutted that by saying we actually did go talk to the specific subject field expert who came up with the current terrestrial refraction calculation from San Diego State. I did not say, because he says this must be true. That's what appeal to authority is. Nor did I say that he agreed with me. That's a straw man fallacy. And you poisoned the well for flat earthers again. And you ad hom and straw man me. Everything that you're doing is fallacious. And if you think that fallacies don't matter, they do. So do I have to keep repeating it again? Maybe Nathan can just pick it up because it's honestly such bad faith. It doesn't make any sense to continue going on. Nathan said that despite the conditions, if we have colder temperatures, warmer temperatures, right? If you don't have certain temperature differentials, we still see the laser too far. In reality, in lab settings, when we test refractive indexes, we see that it does different things in different conditions. When we go out into the world, in all those conditions, we see the laser too far, which directly refutes your terrestrial refraction claim, which you just say the word out loud and hand wave dismiss the observations. Can you rebut the point specifically without misrepresenting what I just said and constantly personally attacking me? Thank you.
Okay, can you point to the paper that supports your position from, what was his name? Thomas Young of San Diego State is what you said. No, Witsit, San Diego State. Could you please provide a link to this authority that you seem to be drawing on? Because what I referenced was scientific consensus, which isn't an appeal to authority. It's actually a misapplication of a fallacy by saying that's an appeal to authority. So again, you don't know how fallacies work. You've got no idea how they apply. Basically, appealing to the process of science being the most accurate way we have of evaluating the world is not an appeal to authority. But, you know, you don't seem to understand how fallacies apply. Like when you say something, that's not a straw man. It's just taking what you've said and you get to clarify that. That's fine. You know, this whole idea that everybody's always making fallacies about you. Maybe you should look up the fallacy and find out what that is. But notice how Witsit has yet deflected straight into this meta argument, this silly back and forth. Oh, you're just picking on me kind of thing. You know, he just wants to derail the argument. I'd love if you actually answered some of our questions and like maybe showed how on flat Earth how the circumpolar stars work. The very first question I have, because you still haven't addressed that. You still haven't done anything. All you've done is hand wave and go, no, it works on flat Earth. Bye.
Okay, maybe you should actually go back and watch the debate, and you'll see that the first thing I did was address the solar or the Southern Star Trails. The first thing I did in the debate, Mark. Okay. Secondly, to correct you for the second consecutive time, I didn't appeal to the authority of anyone. Appeal to authority is saying, this authority says this, it must be true. What I did was respond to your claim that no one that is the authority agrees, and they study it all the time. I said, we talked to those people. This is what they said about your claim. This is what they said about your claim, because I have to correct your claim because you're ignorant of your claim. Okay.
So they think the Earth's flat.
You're being impulsive because I'm exposing you. So the reason that it was a lie and it was a straw man when I said light just does all kinds of things is because you left out the context, which is what I said. Yeah, light does all kinds of things relative to conditions, and Nathan's showing that despite the conditions, if you take your refraction claim and compare it to the conditions, we still see the laser in all those conditions. You left all the context out and said, all you're saying, light does a bunch of crazy things. That's all you're saying. Yeah. That's a straw man fallacy. What I said was, relative to conditions, when we take your claim of refraction relative to those conditions and we go observe the conditions and the lasers, we see them when we shouldn't relative to your refraction claim that invokes certain conditions. If you can respond specifically, that'd be great. You cannot. So I'll just probably hand it over to Nathan after this, because you will not respond specifically to what I just said. That's 3 times in a row. It's why it's a waste of time.
Mark, no, just quickly.
No. There's no way you're getting away with this. You came in and you basically hand waved the circumpolar stars, saying, oh, you just misunderstand how it works. Did not explain anything. Did not explain how it works on a flat Earth. Does not explain why when you look south from Australia, Africa, South America, you see the same circumpolar stars with no lateral movement to move them around to south of another continent. You didn't explain that. You just hand waved and said, oh, they just misunderstand. Then explain it. You didn't address it at all. And this whole idea, oh, I didn't use an appeal to authority to anyone. You've been sitting here saying, oh, I talked to Thomas Young, and Thomas Young said that I'm right. Does Thomas Young think that the Earth is flat? I will bet you they don't. And none of the people that you bring up think the Earth is flat. None of them. And you're just name dropping to try and use this appeal to authority to say, hey, I talked to this person and they said this. Who's this person? Where do they go? For some reason, it's San Diego State. But you won't give us any kind of link to see who they are. You won't give us any kind of link to any paper they've said that backs you up. All you're doing is just basically saying, hey, they agree with me. Flat Earth, flat Earth. No, it's the most worst, grotesque appeal to authority I've ever seen. And quite frankly, I'm sick of you using your fallacies incorrectly. So when you have actually something to talk about, instead of just saying, hey, you misunderstand how these things work. The whole point is you said light does some things in change of conditions, but you won't explain what conditions causes which parts of the light to bend and not bend. You won't do that. All you do is say, oh, well, light does some things, and that's it. And that's not a straw man. Okay. That's what you actually said. Okay,
Nathan, let me respond one more time.
No, man.
David, I walked away for 20 minutes, bud.
No, you had two.
All right. That's not anybody's fault.
Mark, I'm going to respond.
You walk away.
That's not all right, gentlemen, hold on one second.
I'll walk away, and then I'll get
what I'm going to do is kick it over to Nathan.
We've been going
back
and
a chance to respond. and then we'll kick it back over to, let's see, who haven't we heard for a while? Are you
So
waiting?
this dude's just
me?
gonna go on a monologue, like insulting me, and
Wait, I was handing it
Who's
over to.
insulted
Hold
you?
on, shut up for you both of you.
This is
I was
bad.
about to hand it over to Nathan. Why are you upset with me, Nathan or Witsit? I was
Did you
giving
not
it to
just hear
Nathan.
everything he said? So it's like the reason that I have to keep responding is because it's blatant lies and misrepresentation, so that have to be corrected. So basically, the way the debate is they want to end it with the misrepresentation, and
this
then
ain't
shift
over.
subjects.
Oh, David,
Okay,
shut
whatever,
up.
dude,
Like,
whatever, bro.
seriously,
I don't even
David,
care.
this is the first time I've
and
ever
then now
been
people are
tempted-
acting like
Hold
I'm
on,
like acting like a
one
baby
second
because I
so
actually
can-
have logic and know
can
how to
I-
debate.
Will you give me a second so I can chew out David? David, this is the first time I've ever been tempted to boot someone because I'm just like, for crying out loud, like while I'm talking, you purposely unmute yourself to try to speak over me to get a quip at Witsit. Like you're a grown adult. You have to exercise some self-control, self-regulation. Like, how do you not get like speeding tickets every 8 seconds if you can't just keep yourself on mute and not interrupt even while I'm talking? I just can't fathom. Like, I'm the only one here, the agent of order, the only one that's trying to keep this so that it's not going fully off the rails. And you still, even me, you interrupt. Okay, so I want to give Nathan a chance to respond. Is Witsit, we'll come back to you so we can even come back on this very same topic. But the reason I'm deferring to Nathan is because all three of you, David, Mark, and Austin, were all wanting time. And I do want to give Nathan a chance because we haven't heard from him for a bit. So then we'll, like I said, we can go over to Mark and David, and then we can go over to you, Austin. But I do want to just get a chance from Nathan for a quick rebuttal. Go ahead, Nathan.
So as far as like with science, appealing to authority is something that we can't really do. Or say you did appeal to an authority, you can always check them if they have a hypothesis. You can set up an experiment to confirm or falsify what the hypothesis is. I also think it's the same with consensus in science. You used to have a bunch of doctors who thought that dipping their gloves in a pool of water would help clean their gloves, and this caused a lot of loss of life, unfortunately, until Florence Nightingale came along and she proposed that you wash your hands with running water for better hygiene, and this actually ended up saving a lot of lives. So consensus can be wrong, appeal to authority, but the wonderful thing about science, we can always check these things, we can always confirm or disprove or try to isolate variables. And I do think Austin did say some things about the star trails. I think even in some star programs, people have put in an atmosphere over a flat surface with a single rotating sky, and then they put in the atmosphere, and it does create this sort of effect that we see. Personally, I don't claim to know anything about how the sky works. It could be hyperdimensional. There could be portals. It's a frontier. We can't get there. I can't build a ladder to the sky and start measuring it. But the ground we can empirically determine, just like with the mechanical gyro. The military even had said that the gyro should move. And
I'm going to give you a short bit to wrap up.
Yeah. Okay. So it shows that there's no motion, and I really would like to see if anyone in the globe community, if you can take that 4-light experiment, GROTAONE, GROUTAONE. If you can take his experiment on this light, it's 4 lights, 6-inch observer height, 5, 6, 7, 8 miles. If you can scale that 1-foot high lights, scale that on a curved surface and get the results to show a flat Earth, because flat Earth does explain bottom-up disappearance and things on a flat surface, isolating variables. So just please show your isolated variable claim to show the results we observe in nature. Thank you.
We'll kick it over to David or Mark.
Let me go ahead and get out the way. Oh, sorry. Go ahead, Mark.
No, you go, David. I've been talking. Go, mate.
All right.
No,
So
go, David. Go.
I'm going to share my screen, and we're going to address this silliness about the laser. And then I want to go back to an argument that was never addressed. So just a moment. See if we can get this sharing to work. Just a moment. Sorry. It's very slow all of a sudden.
Usually it's the
I'll try. I'll
It's
try to
usually the-
explain it as I'm sorry, who's speaking? Oh, and that's another thing, moderator. Sometimes I don't hear you. It's like when I jumped in while Witsit was talking, and maybe there was a delay, and it seemed like I was trying to cut you off, but I wasn't trying to.
Oh yeah, that actually, to be fair, that actually does happen sometimes.
Happens to me all the
And
it just
name in particular, there was a guy named Kevin once who was on, and I thought he was interrupting me constantly, and it was just because his Zoom was like on a delay. But so I do believe that does happen sometimes. But in terms of finding the share button, there's usually it's green. So if you wave your cursor at the top or the bottom of the middle of the screen, it'll just have that kind of upward arrow on the little box.
Mm-hmm.
Depending.
And I'm clicking it when I see that there's no speaking, or when I see that Witsit is monologuing. Because here's the other thing: when I look at the amount of back and forth that goes, it's like there's 2 or 3 back and forths between Witsit and whomever, and he's going over the same. So then I jump in. It's not like
no problem. Water under the bridge. Seriously,
All right,
I've talked less than 5% of the total time talked, by the way.
I've
See,
had
that's
way
false.
more. I've had way more antagonistic interchanges with guests before. It's totally cool.
Okay.
No hard feelings. But in terms of your screen sharing, if you do want to share, I just want to see. Are you able to see that button though?
I can only share as a whiteboard. I can't share my actual screen, which is unusual. So I've never
are you
come across
using it in
it
the
like this before.
browser or is it the Zoom app?
I'm using the Zoom app.
Okay, then it definitely. I'm just. Really
Yeah,
not
that's
sure
never
why.
seen this before.
It's not to the left of the whiteboard on the top row.
There's nothing there. It's just whiteboard under basic, and under advanced is computer audio and content from second camera. There's usually supposed to be a portion of screen. Okay.
There you go.
See if
Okay.
this works now. So are you seeing my whole screen or just the portion? Okay, now
It is delayed, so it is
Yeah, it
still
is greatly delayed.
taking a little bit to kick in. You've been going on
Okay.
those websites I told you not to go on, David.
Yeah, I know, right? Playing
Okay.
around. I'm asking for it. That's 2 strikes for me.
It's still loading, just to give you a warning. I don't know if you're able to see it. It's still just
Shucks.
a brown, like a gray screen that it
All right.
says.
Hey, Mark, maybe you could help me out, and then I can talk less anyway.
Yeah,
Can you go to do laser test prove the Earth is flat? If you keyword search that, what I was trying to explain to Nathan, I couldn't seem to get it across to him, and I'm going to make it clear to him with this. And essentially, what it is that if the light is bending downward, then objects that are higher than the laser should show as slightly
Are
higher.
you on spacecenter.nz? Is that where you're going to?
It should be space. Yeah, spacecenter.nz. Yeah.
Yeah.
And I was looking at this after I had made my argument because I was like, okay, this isn't making sense. So
There we go. Now it's showing.
now it's
Yeah, that's
showing.
what I'm sharing.
Oh, okay.
Oh, okay.
Sorry.
Okay, so Nathan, like on the flat Earth, you would see the laser, but on any surface, when the light bends down, the content, I'm trying to think of the word. Objects like mountains and cities will also bend downward, but it's bending downward from a higher angle. So you're going to see
Are you
things that are
assuming that?
higher than the laser. You see what I mean?
So, going off of this diagram here, what it looks like is, at least to me, is that on the left side you have the laser and the camera showing that that's what it would look like on a flat Earth and would be the explanation. And then because we see the laser in the camera, you're now seeing that the globe is saying that the light does bend down. But I think you were also mentioning something about light bending up, and this is an example of downward bending light.
No, what I'm trying to get across to you is that your line of sight is from far. What you're seeing from far away on your line of sight has now been distorted. Okay, everything is distorted to where if the light is bending downward, then you cannot see the laser. The laser is going to appear below you. But if there's a mountain or some other
If it
object,
bends down.
you say,
Agree.
what?
I know. I'm trying to
Right.
follow. Okay.
So that being the case, I was trying to get across to you that in one situation or another, you should see the land itself show as higher in elevation. You should see it in one situation or the other. Either if the light is bending upward, that means everything that's below the light you should see. So that would be like if this were flat, the second image were flat, and you don't see the light. You should therefore see the land. as a bowl. Like, there should be mountains all around you. Flat land should appear as, 300-foot mountains in every direction. And the other thing that I was trying to get across is that the temperature variations, the higher temperatures that create the lower densities, do not correspond to the effect that you claim. It just doesn't.
The paper that I showed in the beginning, I actually got that when I was in chemistry. In my organic chemistry class, they had talked about that was our refractive index lab, and that was the paper saying that if you're not in standard conditions, if you're in standard temperature, if you go above that 21 or higher, you're going to add to your refractive index value of what you measure.
Right. That would cause the light to bend down or up. I'm going to let you answer. I think it caused the light to bend down, but maybe you're going to say it's going to cause the light to bend up.
So you're saying if the light bends down, then why isn't the light being bounced off the ground being bent down as well and looks like there's a bowl, right?
Well, it's like everything that you're seeing everything that you should see ahead of you is now below you. So things that should be above you should be further down. And then I realized that I was thinking of it from the globe perspective, and I was kind of getting things distorted. So I said, wait a minute. Either way it goes, there should be instances where they can pick. They can say, well, no, the light will bend up or the light will bend down. I say, well, in one of those situations, you should see a bowl-shaped earth around. You should see mountains all the time. And what I'm not understanding is how they have no explanation for that, because when Jeranism, he had to stand up to see the light.
I've got to rush you.
Right? It wasn't. He had to stand up to see the light, which meant the light was bent up.
You can have some of my time to explain this if when
Jeranism did his experiment, when he did his experiment, you would see that laser on the flat Earth, and that laser light was bending upward, right? Because the light was bending downward. He said, Enrique, stand up. And then Enrique, I guess, stood up, and then he saw the light, right? Which meant that the laser had to go higher to be seen, right?
I think that might have had something to do as well with setting the angle from your perspective rather than kind of tilting the camera to look through the hole for its own tube vision, because the lens has its own field of view separate from what we have. But one thing with the thing about Jaren and that night, at that experiment, and I wasn't there, but what I've heard is that who was there were people that were flat earthers, globe earthers, and they all left that night saying that it was inconclusive. Neither side could say, yes, it showed this or that. And apparently maybe it was clipped out of that was like from the middle of the night, or not like the final end. He said interesting, and then everybody left. It was apparently that was from the middle. That's what I've heard.
I've spent too much time. Go ahead.
James,
I'm being a good boy.
No problem.
I wouldn't mind jumping in and sort of addressing. Can we finish with this screen? Is that okay? Yeah. Okay. Fantastic. Nathan. So I found the whole idea that a mechanical gyroscope doesn't pick this up, and that was kind of interesting to me. So I looked up, and even though there is a 15 degree per hour drift, it's very weak. Apparently, it's a very, very weak drift. So inertial forces like the mechanisms that you're using and the fluid dynamics can basically obscure this 15 degree hour per drift. And that gets me back to my point of, well, why would you use a mechanical one which is less accurate than a ring laser gyroscope? And plus that Foucault pendulum that was shown that, hey, it didn't work. You need a very long string on it to work, because the force, even though it is there, it's very weak. It's a very weak drift because the Earth is not spinning fast. It's spinning 360 degrees over 24 hours, which is not a fast rotation at all. And that Foucault pendulum, if the line is not at least like 5 meters long, it just won't work. So what you were showing was a Foucault pendulum that didn't work because it wasn't long enough to detect the drift. Because if it's too short, it won't detect it. This drift is a very, very weak force.
So with I'll go with the pendulum first, if that's okay. So
Sure.
I'd imagine that this facility, this science facility, and I don't have the name of it. That was on Mitchell from Australia's channel, I believe, was where he was the one that had went to this place, and I can't imagine that this science facility would put that pendulum up if it didn't regularly work. But there are also people who have talked to, like, people who install these pendulums in a museum, and they say that there are motors or drives, and so there is some level of programming that they install in the museum ones as well. But I think that this facility wouldn't put up a pendulum if it wasn't regularly showing the 15 degrees. I do think also the Elias effect kind of would lend more inclination towards the sky being influential. For whatever reason, the ether, I mean, the Elias effect is during an eclipse, the pendulum changes its swing, and NASA has even has documents on this. But that would indicate that there's something to the sky about it. As far as the gyro goes, so I think it was Foucault himself who had said that he had a gyro back then that was mechanical, that could determine that could show that the Earth moved underneath it. And then our own military here in the U.S. had your Osmax, and I think is saying, you're not from the U.S., but here our military is saying that that a mechanical gyro would be able to show that, especially nowadays with our high precision machined gyros, that these mechanical gyros themselves would be subject and sensitive enough to determine this. Why you would use a mechanical versus a ring laser is because a ring laser, a flat Earth cosmology can explain away by saying it's ether. So you use something physical that would only be determined and influenced by the physical Earth turning, because the ether, claiming the ether covers light motion, would be shown in this ring laser gyro, which is what a ring laser gyro picks up, and those are also calibrated. And like, kind of one thing that I've not really understood is why, like, if you hop on a plane with a mechanical gyro or anything, like, why wouldn't you? The whole point of a gyro is to determine your orientation in three-dimensional space. So to have a plane calibrate out one of the axis of rotation, the yaw, I think it is, why wouldn't you want a plane to show, once you've flown to the other side of a globe, that it's upside down? Because you're losing information about your true orientation. So I think that the mechanical gyro should and is even claimed militarily to be sensitive enough to show, and it does not. But then again, a flat Earth has to explain, why do you get this rotation? Ether is what light travels through, and if that light is going through the ring laser gyro, it's going to pick up some of that rotation. It's going to pick up that rotation very accurately.
Hey, Mark, can I ask a quick question? I don't want to take hardly any time. One, and actually, Mark, is for you. A gyro, when it drifts, the drift is consistent with our latitude, right? Like, if it was near the North Pole, there would be very little drift. So then Nathan's argument doesn't make sense then, because there's another coincidence that he says, oh, hey, there's all this ether going on. Well, the ether just happens to cause the gyros to not only drift as if we're on 24,000 miles, 15 degrees, but it's 15 degrees. That's 15 degrees if you're like 100 miles from the North Pole, 100 miles from the South Pole, 1,000 miles. So all of this going on somehow causes these light gyros to do this. And as far as the airplanes go, there is no airplane except for maybe the latest bomber that goes all the way around the Earth. They didn't, and at that time they didn't have air flights that went all the way around the Earth. So that doesn't even make any sense. So, but that was the context of what I wanted to say, Mark. If you're going to respond to that, I just wanted to throw that in there.
Yeah, I just sort of, for me, Nathan, it just appealing to an aether, which is sort of undocumented. You can't tell me anything about it. You've likened it to quantum foam, and physicists don't sort of support this idea of an aether or quantum foam being aether. Like, sort of, I could say, hey, it's just a magical field. I could appeal to something, but that's just a post hoc rationalization for a phenomenon that we see. I think in some way you have to demonstrate that ether is causing this, and then make some predictions about how it's causing it and explain it, rather than just sort of using it as an appeal. Because when they talk about sort of quantum effects, they will actually put substance to those effects, not just sort of say, well, 15 degrees per hour, it looks like it's a rotational drift, but ether, that just doesn't explain anything to me.
I think it would be, if we look at the stars and they are light, we can say, okay, this is a light that is turning, so this must have some sort of influence on light, and then we get that here. And you get the 15-degree turning of the sky is the same. It's 15 degrees no matter where we are on the ground. So no matter where you are, close to the pole, close to the equator, you're going to get that same 15 degrees. And I do think it is kind of, you could say it's kind of post hoc to go ether, but I think you can correlate it with light up above and say, okay, this is a light determining thing. But then it's also, I mean, on the globe model, it is sort of the same. When they added up the mass of the observable universe, it was like 1/25 of what's required for like the expansion of the universe. And so they had to say, okay, there's dark matter, dark energy that is propelling it away, which we also are not able to, and there's nothing like to pose an idea is one thing, and saying you can't measure it or anything, because I don't think I could be handed space-time fabric or dark matter. So I think that kind of thing goes on both sides, but I think we can infer that if we see light up above and it's rotating, that there's something that is that light is rotating with and traveling through, has to have a medium, or as far as our understanding of science, that light has to have a medium. And so I think it kind of goes the same way. But I mean, and I won't like dark energy, like where does that come from other than to balance mathematics? But I get what you're saying, but I think we can correlate it by seeing light in the stars that is moving. We can say, okay, light must move through this, and that's why we pick it up in the ring.
We've got to go into the Q&A.
I just want to say
soon.
something real quick, that the 15 degree per hour drift exactly matches the circumpolar star rotation. So somehow you've got to explain how ether causes both a ring laser gyroscope to drift, a focal pendulum to drift, even though that's not light, that's a physical medium, as well as the stars to match up exactly with the rotation, and why that would exactly match the day-night cycle of the Earth.
Look, I don't know why you don't understand the basic aspect of this, bro. Like, it's just insane. Like, we have sidereal rotation.
Right.
We have sidereal rotation. You guys claim that it's the Earth rotating. Okay. And just to correct you earlier, like I said, you're wrong. Actually, Einstein didn't predict Mercury's perihelion. It's still called the Mercury's anomaly, and it's still not explained yet. To use a massless path for Schwarzschild equation. But anyway, the anomalous rate of precession of the perihelion of Mercury's orbit was first recognized in 1859, just like I said, like 60 years before Einstein even proposed the theory of relativity. So it didn't predict anything. It tried to explain it with math, and it couldn't. It had to use the Schwarzschild equation, which used a massless path. When it comes to the ether, I just told you, and I can show it in a second. It's just unfortunate because I only have, I guess, a few minutes here, but I could read 7 different top-level physicists of today saying there is, in fact, an ether, and we were wrong. It was improperly discarded. I can read Einstein himself saying that there was an ether. When he said there wasn't an ether, he misspoke, and that space without ether is unthinkable. When it comes to the drift, we have 15 degrees, which is not perfectly 15 degrees, and a sidereal rotation, and it's the sky moving. You guys claim it's the Earth moving. So we detect that motion with ring laser gyros. We're trying to figure out what it is. Just like Einstein said, either it could be the sky moving or it could be the Earth moving. He was right about a couple things, and that's one of them. Okay. And so that's what Nathan's explaining to you. You keep on saying it just happens to match perfect. No, the globe model and all of the predictions of axial rotation came from the sidereal rotation observation. And then you actually attributed that to axial rotation, claiming that the stars were in a fixed position. So it's a pretty simple thing, and I don't know why it's just not understood.
Hey, Mark, do you know about like how the gyro works with the X, Y, and Z coordinates. I'm not that familiar.
Well, call him after
What,
the debate.
No, I don't want to call. I want to ask him now.
Well,
what, the ring laser
that's
gyroscope?
weird.
Yeah, by Witsit. So my understanding is that there's an X, Y, and Z.
Yes.
No,
Well,
all
the
three of the
37th
coordinates.
time, my point just gets
Right.
dismissed.
So Witsit, you had your time to talk, and I, being a good boy, did not interrupt.
Crazy,
Bye-bye.
bro.
Yeah. So in any event, so
Witsit
the X,
just
Y,
wants to
and
change
Z.
the topic.
No.
Yeah,
You two
he
want to
knows
talk
where
to
I'm
each
going.
other in a debate?
Yes, we do. Thank you. So what I'm trying to
I do want
understand is
you.
that,
I do. It does make sense. We want you, like, if you're addressing Austin's arguments, go ahead and address him. I mean, unless you're.
He's
If you
ignoring my
want to defer
argument.
to Mark to
Yeah,
respond
so-
to Austin, go ahead. But
Yeah,
right, I
okay,
wanna
so I'll
ma-
respond to Witsit then. Sort of calling on saying these scientists acknowledge aether. Witsit still can't show any paper that says that aether is a thing, or much less that it has any kind of effect on light in the way that they're sort of trying to claim it does. This is a crutch. This is basically just, we can't explain this. Oh, aether. I could make the same argument for magic and say that physicists have now found magic, you know, in quantum physics, and then they're just using this, you know, I'm just giving it a different name. But they're not saying that, the physicists aren't saying that aether is what's causing these things to occur. They're sort of saying, is someone like sharing their screen over the top of me? Okay, that's weird. They're not saying that. They're saying that this is caused by the Earth's rotation. They're not saying aether is causing it. So if Witsit can show me a paper that says that aether is causing it, that would be great.
Okay.
and I
I
was
do want to, in the future, I do want to ask if you guys can wait to share, as well as one thing that I'm starting to get to, especially because you've just triggered me so much tonight, David. I'm not as fond of the other guys talking, holding up flashcards that say a message that you wanted to say to the audience. I get it. I get that modern day debate, sometimes we want to be like the XFL as a fun alternative to the NFL, but the XFL also crashed and burned. And so being a little bit more formal and not having the flashcards while someone is talking, or while not pulling up a screen while someone is talking, that's something I do want to move toward in the future. But go ahead, Austin. It looks like you have something you wanted to respond with in regards to Mark's question.
Yeah, sorry. I mean, I didn't think it would like affect the stream, so if it did, my bad.
No problem.
So today the vacuum is recognized as a rich physical medium. A general theory of the vacuum is thus a theory of everything, a universal theory. It would be appropriate to call the vacuum ether once again. S. Saunders and H.R. Brown, The Philosophy of a Vacuum. This is the father of quantum mechanics, arguably. We have now the velocity at all points of space-time playing a fundamental part in electrodynamics. It is natural to regard it as the velocity of some real physical thing. Thus, with the new theory of electrodynamics, we are rather forced to have an ether. Paul Dirac. Here we go with investigations point towards a compelling idea that all nature is ultimately controlled by the activities of a single superforce. That's a living vacuum. The ether holds the key to a full understanding of the forces of nature. That's Paul Davies' Superforces Search for a Grand Unified Theory. Here is Frank Wilczek, the guy I mentioned earlier who won a Nobel Prize. There are good reasons to think that the universe is a multi-layered, multicolored superconductor, that all four known forces can be brought together in unified theory, that seemingly different kinds of matter are just different aspects of one all-embracing stuff. I anticipate that the next few years will be a new golden age of fundamental physics. He actually wrote this book right here on my desk. It's actually called The Lightness of Being, Mass, the Ether, and the Unification of Forces. Here you have Robert Laughlin from Stanford saying the word ether has extremely negative connotations in theoretical physics because of its past association with the opposition to relativity. This is unfortunate because stripped of these connotations, it rather nicely captures the way most physicists actually think about the vacuum. And here he is again describing that there's a vacuum. So I don't want to just read a bunch of quotes, but when you say that no physicists do it, you're just clearly ignorant of the subject. That's why I brought up the Casimir effect. I brought up vacuum energy, quantum foam. We know that the vacuum is not Newtonian emptiness. We know that Einstein did not properly define exactly what is beyond the material world. He himself said that space without ether is unthinkable. Okay, so you should research it instead of just saying it's not true. You should apply for the audience. You should apply the same critique or skepticism to space-time. If it's like, oh, well, you need to scientifically prove it. You need an experiment. Then you need to apply the same criticism to the fabric of space-time, which doesn't work on the quantum or cosmological scale and has been debunked 1,000 different ways. Okay, this is actually the only viable way. Quantum mechanics has shown it experimentally. So there you go.
Okay, so I'd love to respond to that, because basically what Witsit is doing is dishonestly conflating the idea of aether before general relativity with the idea of they're using aether to reference that as a nice way of describing it. So what he's doing is he's saying, hey, this aether is responsible for all these things that now we know is the theory of relativity, and now he's associating that, because one of those quotes was the theory of everything, which does not exist. We have not got a theory of everything, because there is not a grand unified theory out there. But Witsit doesn't know enough to actually know this, for instance. When they're talking about this sort of quantum foam and vacuum, what I asked was, how does that aether actually cause these things to happen? He hasn't referenced that. All he said is, hey, some people are calling the new phenomenon of things existing, like quantum effects and quantum fields existing where formerly they thought was thought to be a vacuum. They're calling it ether. Therefore, it's the same ether as was referenced in the past, which is a conflation, and a very dishonest one at that, because it is not the same thing. That theory of aether that was debunked ages ago because of those negative connotations, and rightly so, has completely been debunked and thrown out. But that's what he doesn't want you to know. What he wants you to think is that the modern version of quantum physics is referencing the same ether that predated theory of relativity, which it's not. And he knows that. So why would you do that? Why would you try and conflate this idea of quantum physics with the ether that existed before the theory of relativity?
Yeah, such a layup. Thank you for the alley-oop.
So we got to go to the Q&A soon too. So I want to have this be the last response.
So he said quantum foam and all this stuff is explained perfectly by relativity. Literally, it's not explained by relativity at all. You did. Maybe you should watch the debate back. It's embarrassing for you. So it isn't explained by relativity. That's the whole point. You need something additional to space and time there, which is what relativity claims. Again, Einstein himself said that the space without ether is unthinkable, and I misspoke when I said there is no ether. I should have said there is no ether drift. My point is not that it's the same, because these people assume that the Michelson-Morley interpretation is correct. But actually, what you claim disproved it was Michelson-Morley not showing a friendship, which with the Earth stationary, then it perfectly explained with an ether. So the reason that physics is at a standstill, and I know you said I don't understand that there's no unified theory. I know way more about it than you. Right? They actually unified the weak force and the electric force, called the electric weak force. And it was proposed in the 60s. It was disregarded for decades. And now it's integrated into the standard particle physics theory. And it was integrated by Stanford, where they now acknowledge the weak nuclear force is actually electric. There's actually another one for the strong force. They're acknowledging the ether, that it was improperly discarded all around higher levels of academia right now, trying to unify the four fundamental forces. Okay, so that's the actual truth of the situation. The reason that they're at a standstill is because if they claim that there's a substantive background medium that actually sustains electromagnetic energy, then you have to go back and re-explain Michelson-Morley, which they can't explain, because if there's an Earth orbiting around the sun through a substantive background, that's going to cause a drift. It's going to cause a drift in the light, which will give you an interference pattern or a fringe shift. And that's not what was observed. The stationary Earth, you can perfectly explain it. I can give you millions of papers. I can literally hundreds of papers proposing unified field theories and quantum field theories that integrate a background fluid-like medium.
Not proposing, demonstrating that ether, this idea that there is a substance in the background of quantum fields, is causing the 15 degree per hour drift of Earth. You're going to send me a paper saying that, are you?
Did I say that, or did I?
No. Witsit, send me a paper saying that. Yes or no? Will you?
No, I didn't say that. You said
no. Will you or won't you send me a paper that says that the ether is responsible for the 15 degree per hour drift? Are you going to send me a paper, or won't you?
I just said no. I didn't say that.
No, you're not going to, are you? No, that's a big fat no from Witsit. No, you can't demonstrate any of this.
The audience can see.
Well, it was a yes and no question, Witsit. I don't really want to hear your
excuses. No, you think you control things behind the keyboard. I get it.
We've got to go to the Q&A.
What are you talking about? I'm not even using my keyboard. What is wrong with you?
Quick housekeeping type thing. Folks, our guests are linked in the description.
Wow.
That includes if you're listening via the podcast. I've got to say, it has been a lively one. It's been a slobber knocker. We're going to go through these questions as fast as humanly possible, because this is like I know it can't be 7th. Maybe my 6th hour of streaming that we're coming out on today. I'm pretty pooped, but let's finish it strong. So as mentioned, our guests are linked in the description. And thanks so much for your questions. Jumping into it, King044 says, question for Witsit: where does the sun go when it sets? If it's moving away as it sets, can it be brought back into the view using for example, a telescope? If that's the case, can you turn night into day by zooming in? Ding. That's what they said.
Yikes. That's crazy. If you don't know why the sun disappears on a flat Earth yet, of course you think the Earth's the ball, but like nah, it just reaches a limit of perspective, and that position changes. Sometimes we don't see the sun from as far away as we do on other days. According to the globe, it's behind a physical curve, so it should go behind a physical curve. But in reality, which I've done this, thousands of people have done it. When you go see the sun, it actually can be seen from greater distances on different days. Meaning it can be seen longer, it can be seen with greater artifacts or artifacts with greater distances around it. Right, so it just reaches that vanishing point. Once it reaches it, there is no bringing it back. It's beyond the perspective limit combined with the atmospheric conditions. It's like I showed the video 2 debates ago on here where the sun actually disappears into the horizon, not behind the physical one. So no, it reaches the limit of perspective based on optics, which is actual curved visual space and not Euclidean, and the atmospheric conditions.
You got it.
Can
Thank you
I
very much
ask
for this
a
question. I do. We got to move through these, so I do want to ask for at least until we get like at a good pace where we're caught up.
Gotcha.
Let's only have a single response, in particular the person who is addressed for. This one says, Witsit, Kang044 again says, for a truther, you seem to be happy with a lot of ad hoc explanations as long as they fit your bias. I think it's called selective skepticism.
No, not really. Like I admit what I have to speculate about. And other people, like our opponents, they just regurgitate what they were told. So the difference is the true earthers, they like just want to figure out what's going on. They look into it for themselves. They think for themselves. The other side doesn't really do that. So I'm not into ad hoc explanations being misrepresented as definitive reality. Science is a process of learning and figuring things out, an attempt to gain knowledge, which is the etymology of science, to know. We're just trying to know things. And we cannot fully understand things, but we can propose the only logically viable, experimentally viable, and validated theory of the time to move forward. And actually, the globe Earth, the heliocentric model, has tons of ad hoc explanations that go in the face of the evidence, right? Like there's length contraction, but you can't see it, etc. So no, I don't. I'm cool with speculation as long as it's denoted as that, and as long as it's intellectually efficient, meaning it's backed up by the evidence. That is kind of the process of science, is trying to theorize and figure it out. Difference is that the heliocentric model doesn't actually back it up with evidence. They pretend it's definitive.
Let's move forward.
So there you go.
This one from Coconut Cream Pie. No question. I think they just wanted to hear me read their name. This one from Kang044 says, Akashi Kaikyo Bridge, plants, Burj Khalifa, Shanghai Tower, Taipei 101, Petronas Towers in Malaysia, I think that is, One World Trade Center, Kingdom Center, the Shard. All of these buildings take the curvature of the Earth into account. Witsit, you're wrong.
You can see further when you go higher on a flat Earth. Nathan already explained that. And if you think there's a ball, there's no reason to misrepresent basic things like that. That's kind of sketchy. You know? So you can see further.
Sorry,
that's what he's talking about. Is like the Burj Khalifa. You can see the sunset when you're higher. When you're higher, you can see further.
No, he was saying
they
were built taking the curvature of the Earth into account.
Vertical buildings don't account for the curvature of the Earth.
When they're parallel with each other. But
to be fair, they didn't give a citation, so it is just their word against Austin's. Level with Z says 2 versus 2 is too many people debating. Please do 1 versus 1. Thanks for that feedback. Run Boston Bear says Austin knows his stuff on this topic. That's why he can talk to professionals in all fields without drama. We have been lied to. It's time to come together in truth. Science will also benefit. Well, I'll give you a chance, Mark and David.
Yeah, sure.
I would guess you'd disagree.
Yeah, there's no reason why you'd be lied to, and the evidence is absolutely overwhelming. Like, you have to come up with these sort of ad hoc rationalizations like aether and magic and all this kind of stuff in order to explain all of this away. I also note that Witsit didn't explain why the circumpolar rotation happens. There's no explanatory power to what he's saying, while there is for the Earth, and there's no reason why.
I do want to keep it
the people lied to. Yeah, sure. There's no reason why we'd be lied to about this. There's absolutely zero reasons.
This one from Jack Hardgrave says, to both sides, why is it when I look at the stars in Australia, I see the Southern Cross and other constellations, but when I look up in the U.S., where I live now, I see completely different ones? We'll start with the flat side.
Depending on where you're standing on the ground, you're going to have such a sky available to you. So if you're in the north, you're going to see, and you're at 45 degrees, you're going to see Polaris at 45 degrees. As you move south, the sky that is your zenith, the star that's directly above you, is going to start to move. So as that moves with you, that zenith is your center point of your sky available. Everything is going to shift with you. I believe that's the same on both models, but that's different stars are available because it's where you're standing on the ground. Just like if you look up, if you have like popcorn on your ceiling, the popcorn piece that's above you, if you move to another location in your room, you're going to have another piece of popcorn above you.
The globe side, what are your thoughts? David looks ready. Go ahead, David.
Yeah, there's a problem with that because those other stars are rotating, and apparently the dome.
The only trick is, don't get me wrong, but technically they want the answer from the globe side. Well, how you would explain why they see the different constellations. I don't want to get into the rebuttals of questions just because we have so many we've got to get through. So maybe once we got through like a good chunk of them and make good time, but in the meanwhile, I want you, if you can respond to their question directly.
I mean, it's because you're seeing it from a spherical body. You're standing on a spherical Earth, and it fits. Mark showed the animated diagram. I mean, it's just too clear. It's Occam's razor. I don't know what else to say.
You got it. Iron Horse says, "Dear Globies," says, how do weather systems rotate on the spot and move the rotation of the Earth? 200-mile-per-hour winds are destructive, yet still air is 1,000 miles per hour.
Yeah, so as I've told Iron Horse again and again and again, there's inertial reference frames. So anything in motion will remain in motion. Anything still will remain still until another force is acted upon it. So the idea that the Earth is spinning, but the air should stay where it is. The air is sort of moving with the Earth. If he's asking why winds form, it's convection, basically. So I don't know what he's talking about with that one.
And it's been moving for millions of years. So it's not like it started yesterday and there's this big shift of 1,000 miles. There's no acceleration of 1,000 miles that we have to take into account.
Didn't answer his question.
That was a direct answer.
This one coming from Upside Down Guy says, my hamster, Ham deGrasse Tyson, believes his hamster wheel proves Earth is a sphere even though it looks flat. How high does Ham deGrasse Tyson need to go from his cage to see Earth curve? How high do you have to go to see Earth curve? Is there actually like a standard answer from each side on this? Like how many feet or miles?
Couple hundred miles.
I don't think so. I mean, basically, Neil deGrasse Tyson famously said you can't see Earth's curvature for a certain distance up. But what he was talking about is just observation with the naked eye. If you actually do some precise measurements, you can actually see it. Like if you basically squeeze the frame, for instance, and you can see the curvature. So we can observe the curvature from a sort of a fair way up. It's been observed from weather balloons, high altitude weather balloons and things like that using flat lenses. But I mean, a hamster wheel is tiny. I'm not sure what that's got to do with anything. Sorry, David.
How many feet, David? You know?
No, I don't need to say anything. You guys are good. Yeah.
All right. And then Austin and Nathan, is there well, I suppose you guys would say you never see the curvature because it's flat. This one coming in from Chris Wagner says, Bangarang, Witsit. This one from Kango44, which is like one of my favorite phrases, by the way, says, with your in-depth knowledge of quantum mechanics, can you please explain a sunset? Bangarang.
I just explained the sunset. Like, if you can't understand the sun on a plane, I don't know what to do for you. It reaches the limit of perspective moving away from you on a plane. And actually, I don't even claim a physical actual position. We've actually mapped it out. It seems to be like a magnetic toroidal position, but either one works.
Once it's beyond your vanishing point, it's vanished.
No, that's not how vanishing points work. Sorry,
Profound.
guys. Well, that's not how they work.
I'm sure it'll come up in another question. I hate doing
Yeah.
this, but I just want to keep moving because otherwise a lot of people will be unhappy. So this one, Coconut Cream Pie, strikes again. Says for Witsit, for major scientific claims, you need a model that can make testable, falsifiable, and correct predictions. Otherwise, the claim is worthless. I ask, can the flat Earth model predict weather?
Yeah, of course. Like you can map it out on an azimuthal projection. But what's so funny, bro, is like models aren't like this all-encompassing thing. There isn't a globe model that explains everything, right? Like you have a globe model to try to explain this. For example, you have the geomagnetic field. That's the dynamo model. It's called the geodynamo model. That's a specific model to try to explain a specific phenomena, which is convection currents coming from a molten iron core with nickel and iron spinning and causing a magnetic field, which is completely off. You have the South Atlantic anomaly, it's 25% weaker when it should be symmetry in the north and the south, and like 50 other problems. My point is that you have different models for different phenomena. We can explain all kinds of phenomena with the flat Earth, right? We have models for all kinds of stuff, like the magnetic field works better there, the data matches. So you guys should stop saying the model thing. It doesn't make any sense. It's like, oh, well, if we can't explain one thing on the flat Earth model is debunked. But if we can't explain 500 things on the globe Earth, well, that's just the part of the model that science is working on. Like, try to be consistent.
This from Displays Gamer says, is there a firmament? Is it the same distance from the ground to the top of all points? Why do you not see refraction as light moves past the firmament in the upward direction?
That a globe, or can anyone answer? Or
I think, assuming you believe, like Austin
That's
or
probably a
Nathan
flat
might believe in the
Earth.
Probably a
firmament.
flatter one.
I think they're saying, assuming a firmament, is it the same distance from the ground to the top of all points to the firmament? I assume yes. And then they say, why do you not see refraction as light moves past the firmament in the upward direction?
You got it.
So like as far as the firmament, does it come down 1,000 miles into the Antarctica track, or does it come down way further out? We don't really know like the shape of it as far as like the domeness to it, or like how much curvature to the dome that there is of the sky, and what exactly it's made out of. I would say these things have some not quite understood frontiers, but we on either model, where you see that star is, I mean, that's a star right above you. If I look at Polaris, it's there, and it has to be explained why it's there and been there for a very long time on both models.
Some claim that it's the same height, like as in flat. Some claim it's like a dome and that it would be different heights. So like we don't have to make claims we can't verify.
Alternate Keck says, fact, if the world was flat, then if you obtained a high enough altitude, you could use a telescope to view any country on the Earth. Demonstrate proof. I don't know if they mean proof that he's wrong or proof of the flat Earth, but we'll give you a chance to respond, Nathan and Austin.
One book you should read is this right here, which is Geometries of Visual Space by Mark Wagner. And it explains that the way that we perceive visual space is actually non-Euclidean and curved, which is why railroads, although in tangible reality are parallel, they appear to converge. We actually view visual space in curved visual space. That's how we view it. So, of course, you wouldn't see it. It would converge down to a singular point. And that's how the eyes work, hence them being curved. And so we reach the limit of perspective. Also, you have something called the attenuation of light. So you have a perspective limit and attenuation of light. You would not see forever, and it's incredibly ignorant position.
You can see so far, and things shrink. Oh, sorry.
Go ahead. You're right.
So yeah, as things get further away, they shrink. And then if you are going to try to look at something, say on the other side of the ocean, you're going to run into things like debris in the atmosphere, like dust. You're also going to get water vapor. Magnification, when you zoom in on something, you're crowding out everything around it to make that thing you're looking at appear bigger. So that magnification is going to wash out everything as well. So it'd be like trying to look across the ocean, but I'm going to hold like an inch of dust in front of your lens as well.
This
like
one.
solid opaque dust. So
this
and
one from
King044
says, Witsit, this sounds a lot like a last question from a few questions ago. It's not. It's slightly different. They say, given your in-depth knowledge of, instead of quantum physics, relativity and special relativity, can you explain the sunset?
It reaches the limit of perspective, man. You're like 7 years behind, bro.
Alternate Keck says you can use the world of Warcraft to simulate a flat Earth, and it clearly demonstrates a flat Earth model which looks nothing like the sphere reality.
Wow. I didn't even got what do you say to that?
So like if I have a flat surface here, like as far as like models go and everything, this could be a flat surface. And if I say that this is the pole, I can walk in a circle and model how you can circumnavigate on a flat surface. So it depends on if you have like a square and just top down, left, right, or if you put the center attractive point in the center, and then you can go around it. So yeah, I don't. They use a flat model because it's our intuitive sense is that things are flat. All video games and everything use flat Earths, and except for like No Man's Sky and all that stuff. But the flat is intuitive, easy to model off of and build off of. But models are like that right there. That example was a model. So models, there are flat models, spherical models, and stuff. So
you got it. This one from Zarax Zarzaren says, Flurfs, why do you say Einstein approves of the ether when all quotes of him disprove the ether? Please give quotes.
Okay, I'll easily give you a quote right now. So it would have been more correct if I had limited myself in my earlier publications to emphasizing only the non-existence of an ether velocity instead of arguing the total non-existence of the ether. Or I can see that with the word ether, we say nothing else, and that space has to be viewed as a carrier of physical properties. Albert Einstein, in a letter to Hendrik Lorentz in 1919, he also said, it would have been more correct if I had limited myself to assert that the word ether has changed its meaning many times in the development of science. At the moment, it no longer stands for a medium built up of particles. Its story, by no means finished, is continued by the theory of relativity. Albert Einstein, The Evolution of Physics, 1938. Thanks for playing.
This one from Hate Stare says, Flurfs, gas equally fills the volume of a container. Why isn't air pressure evenly distributed vertically, and why is there a pressure gradient?
So gas is considered a fluid, just like a liquid. They're two separate phases of matter, but they are both considered fluid, and fluids do separate out by density. So denser particles will settle at the bottom. This atmosphere down here, atmo is denser than as you go up. But you do have to have a container for this medium to form. If you look at density towers of like different fluids, like water, honey, corn, maple syrup, and all that stuff, it has to be in a container. Gases as well, they will sort out into density tower essentially, and you get the least pressure at the top.
You got it. Dave Hinkle says, Globers, please provide direct measure of Earth's curvature over a body of water, clearly showing the 66-foot drop in elevation.
Yeah, that isn't how Earth curvature is actually calculated. So you can calculate Earth curvature very easily, but it's not just a matter of distance equals drop, because there also is the height of the observer to take into account. There's refractive index to take into account. There's a lot of things to take into account. Look, geodetic survey does that all the time. Like they do take the curvature of the Earth when they're doing geodetic survey. So these measurements are made all the time. Just because you don't, see the surveyors actually do large enough areas to take the curvature into account doesn't mean they're not doing geodetic surveys.
This one coming in from, do appreciate your question, Nick. A piercing, scathing criticism for you, David. Says, for David,
Yay.
Are you aware that the way you act and your inability to describe your examples and defend your model actually, in all caps, does a disservice to the globe model and pushes people to the flat Earth side?
Let's see. So he spoke of a vanishing point and how, I guess because the word vanishing is in there, they have presumed that objects can go so far away that you'll never be able to see them, not even with a telescope. Well, those stars that are on your dome are apparently further away than that, and we see them. And what a vanishing point is supposed to explain, and I guess you guys have misunderstood, is that it means that objects that are of a particular distance apart, as you get further and further away, they are so close together that you cannot discern them. They're, essentially a point. And that is why they call it a vanishing point. It's not because objects can never be seen beyond a certain distance. And your flat Earth stars prove it.
This one coming in from, do appreciate it,
Yes.
Christopher Custon says, Flat Earthers, did you understand Mark's explanation for looking farther? If you did, you would be able to see the edge or past the ice wall.
Perfect.
Globe W.
Perfect time to like address what David's saying and answer the question. Okay. So we actually see, we have curved retinas. So we see a Euclidean plane geometry Earth and non-Euclidean hyperbolic curved visual space. That we have curved retinas. This again is why we have tangible reality, parallel railroads, they converge. So whenever he's saying, oh, well, no, that when you look at the sky, it's different. Well, I explained it's also combined with atmospheric conditions. That acts as like an additional lens, right? So that additional lens on top of what we're seeing is exaggerating that curved visual space effect, which creates a convergence into a limit of perspective. Well documented, easily provable.
You got it. This one
essentially you have the ground going up and the sky going down, and then once you get to that point, the sky would keep going if the ground wasn't there, going down in your vision, and the ground would keep going up, but they cancel each other out. And so if you try to see anything beyond on the ground, that sky is going to essentially create that blockage, and it's going to take priority and cut off anything beyond that point. And the stars don't have a thick atmosphere when you look up. It thins out as you go up.
Correct.
You got it. This one coming in from, do appreciate your question. Zarin says, Flurfs, the globes, quote unquote, showed scientific papers. I think they mean by globes. Well, yeah. They say you showed hand-drawn pictures, which is more accurate.
None of them showed scientific papers. He showed CGI animations and like with the stars right beside the globe as if it's like an accurate depiction. There's tons of, listen, man, everyone is under the assumption that the Earth's a ball in a heliocentric model, right? So all the scientists are trying to explain within that paradigm. Like they're like, oh, magnetic field. Let me explain it within the globe Earth, and it's not working, but they assume the globe. So that doesn't prove it. And if we invoke them as hostile witnesses because we have to correct misunderstandings of the globe, like, no, actually the magnetic field doesn't work, here's all the discrepancies, that doesn't mean that we have to claim that they think the Earth is flat. Doesn't mean we have to believe everything that they believe. That's a fundamental, like, elementary fallacy, okay? So we can't invoke a ton of papers as it wouldn't even be accepted. I know physicists that have proposed geocentric papers that are flawless and irrefutable, and they're not published, okay? So there's actually a philosophical bias in science. You can't propose something that goes against mainstream cosmological model, and this is a fact. And we have proof that they accepted the geocentric paper, saw that the math was perfect, found out he was a geocentrist, and turned down his future papers. It's provable. It's on record.
This one,
and I can actually attest to that with my biology teacher saying that I can't propose a paper that gets submitted for peer review. I have to become a degreed practicing scientist in the field doing research and then go through all of these steps. Science is not an open thing. It is essentially a barrier when the experiments and results themselves should be able to shut down anyone just trying to pitch some woo.
Nice.
This one from Squid Super Hunk says, a lively Saturday night debate. Always especially enjoy getting to hear Mark do his thing. You got a fan out there, Mark. Upside Down Guy says, here you go again. My hamster, Kytham Jenner, is transgendered and identifies as a fish. Kytham Jenner wants to swim the Mississippi River. How is it possible that long rivers are able to flow one direction over the curve?
Mark, you want me to try it? It's an easy one.
Yeah, go
ahead.
Yeah, go, David. Yeah.
Okay, so the force of gravity is not linear. There's a point. There's a center point, and so as you're moving along the surface of the Earth, what's pulling at you is tangent to where you're standing, to the center of the Earth at that moment. So it's not that you started over here and gravity is going there, and then the curve is curving down, and then it's still this way. There's a point down here, and wherever you are from that center point on Earth is what's pulling you directly down from that spot where you stand.
You got it. This one coming in from, do appreciate your question. Anthony Chicante says, God bless you, James, for being brave enough to host Flat Earth debates. Thanks for your kind words. Says, it's a controversial subject, and all sorts of hate can come your way for even considering it a debatable topic. God bless you, bro. Thanks so much for your kind words. We don't get too much hate, although there are some people who are like, why are we having flat Earth again? But anyway, Zarzurin, thanks for your super chat question, says, Nathan, please explain the motion of stars in northern and southern hemisphere. Scientific. I think they mean explain
so the stars they move east to west, and actually I can hop in. So Mark had said in the beginning, he had said if you are standing at the bottom of say the Big Dipper and you see it going this way, but then this person over here is seeing it go this way, that's all depending on where you're standing. That person is gonna always see going east to west for the stars, and it also does go. So then if you are standing at the equator, the stars are going to go straight east and then head straight west. So you get those straight lines. And then if you're looking south, it flips because now the equator is behind you this way. So everything is still going east to west, but the direction that it appears to us is flipped.
You got it.
Because
Thank you.
behind the equator? Sorry.
Can I just point out that's not what I was saying, that it looks different to a different observer. What I was saying is that the circumpolar rotation, if your flat Earth paradigm is true, it's like half of it is not going east to west, it's going west to east, because the only reason we say it's going east to west is because under that circumpolar rotation, we're looking past the South Pole and saying, oh, well, the star's going in the other direction is reversed. But that paradigm doesn't exist on a flat Earth because you're not looking past the South Pole.
If you look in the opposite direction of a 6 and a 9 or so, and they flip, and of course we can show with a container over top of concentric circles on a plane, you can actually get that same exact effect in the south where you have convergence. And again, Walter Bislin shows it mapped out. Every single square inch of the Earth is mapped out exactly how the stars work. I answered this at the beginning of the debate.
That doesn't explain it at all.
There you go.
Without that South Pole rotation, it doesn't explain why.
It's called an azimuthal grid of vision. Azimuthal grid of vision, and it causes a personal perception of convergence. Look it up.
Why would the equator
I hate
be
to do
relevant?
this.
That's
We do have to keep moving. We just
You'll
have
get there.
so many questions. We're making good time. So like we may get to that point. This one from Tons says, David has only a basic understanding of anything he talks about. Even if Austin is wrong, which he isn't, David wouldn't understand him anyways. Go ahead, David. Now's your chance.
Oh my gosh! I hope I don't make a fool of myself here. The gyros, the motion, the XY motion of the gyros, because it's not just the Z motion that shows the drift, but there's the X and Y motion, and those X and Y motions correspond to your position along the Earth. Like on the surface, relative to that. That's where the drift comes from. So there's a problem. The rate of the drift on the X and Y coordinates is consistent from the North Pole. If you're on a flat Earth, just imagine you're on a flat Earth. It's consistent from the North Pole to the equator. But then it's like it's less of a drift when you account for how much distance you have to go around that flat Earth on the southern hemisphere. It's like for every mile of X that's lost, and Y that's lost is you're going around the flat curve of a particular latitude. You're losing like dozens of miles by the time you get to like the southern parts of Australia. Okay, so there's one thing. The other thing is that the stars that are closer. The stars that are shown on the horizon are still further away than these flat Earth arguments about the vanishing point. I can still see stars on the horizon, and those stars are much further than any point on a flat Earth model. And last thing is, you guys speak about how the eye has some kind of dynamics that causes you to see things curve downward. Well, that's only an optical effect. That's not a physical effect. It's not a magnetic effect. It's an optical effect. So I should be able to turn upside down, right? Stand on my head, and I should see all that sky go up and see all that land go up as well.
You don't understand it.
There's no explanation that you can give that is coherent. I'm unpacking your incoherent explanations, and yes, sometimes it can sound absurd. Yes, go ahead, do your eye, do your act. It's fine.
This one, we must.
I can't
move forward.
respond, so
basic
just
logic.
whatever.
I've got to move forward. I hate to do it, but this one from Displaced Gamer says, "Can all speakers explain the difference between magic and science? Then give a short explanation on how the Earth was formed." Just curious.
Yeah, I mean, I can grab that. Difference between magic and science is that science is a process that is followed, a methodology for finding out in a reliable, robust, rigorous way what the physical properties of the reality actually are. It's not a perfect methodology. I don't think there is a perfect methodology, but it is the best methodology we have so far to demonstrate what is actually true and what is not. Under a scientific explanation, the formation of the Earth was basically elements, an accretion disk of elements, heavy elements coming together, making the core of the Earth, while the lighter elements, under the effect of gravity, made the Earth what it is. The Moon, we believe, is when another planetoid hit the surface, dislodging a chunk. So all of this has got a lot of science behind it. And that methodology is sort of the inductive process that we go through.
So fairy tales.
I said it was inductive
All right,
process.
let's just keep it
magic is the
responding
fairy
to the
tale.
question.
That's the fairy tale.
Keeping it on the question.
Oh yeah, this is a fairy tale that the Earth was
On the
formed out
question.
of the
We have to
dust
keep
of
it on the
sun.
question, otherwise they're going to go on forever.
Yeah.
And we've got
Witsit.
Oh, that's what I'm
so many
saying.
more
They're saying that
questions.
the Earth is formed out of the dust particles from the sun. And they replaced Genesis with a new
I never said
creation
sun.
story,
We must-
and that's
we-
the
we
current
have to go.
consensus.
We have
I
to
never
keep
said
moving.
sun.
We have to keep moving, gentlemen.
Okay, sorry. I
This is
thought
everybody
you said
gets a
keep it on
chance.
the question. Go ahead.
Everybody gets a chance for answering this question directly. Like, in other words, the person is asking difference between magic and science.
Oh.
how they
I think that science is something that it's an empirical process where you make an observation, you form a hypothesis, you can set up an experiment with given observational definitions. You are able to carry out procedures, get a result, and then you draw your conclusions. You should be able to hand someone those procedures that you did, and then they can recreate the experiment with the same conditions. You should get the same result, and then you are able to kind of confirm things, especially with isolated variables. You can do controls and variables. As far as magic, I think that's something that people do to maybe for entertainment at a party or something, but or to like to calm people. But magic, I think there's other types of magic as well, but I don't know if we want to get into like some darker stuff like Crowley magic and all that. So let's just, I'll go there if anyone wants to, but.
Anybody else?
Science is good.
I must have missed the question. The difference in science and magic, science is empirical, testable. It's outside of philosophical bias, personal opinions. You just go figure out what it is, then you accept it for what it is and try to understand it. Philosophical bias of the Copernican principle that the Earth has no special place, or let me come up with how I think everything came from nothing and all this stuff. That's not science. That's basically invoking magic, theoretical magic, right? So that's what I would claim. That's the only way I can even tie the two together specifically. So,
anything else on? Anybody want to add anything on how the Earth was formed that wasn't already said by your teammate? Cool.
It was intelligently designed.
I believe that a creator. I believe Jesus put this Earth here. So
magic.
James, you asked how it was created, right? That
Roughly speaking, and in the super abbreviated way.
Right, and so not who created it, but how it was created. So I could say God created the Earth through the natural processes that has been agreed upon by conventional science.
No one agrees on.
We didn't ask who made it. We just asked how it was made.
No one agrees on how the Earth was made.
It doesn't matter. They asked us a question. I'm answering it.
This one coming in from Nick says, Mark, what makes the Foucault pendulum different from large crane cables, and why aren't those moving all around when not in use?
So what makes it different than large crane cables? Well, the Foucault pendulum depends on a specific weight that is attached to it, and it shows the drift. There's a lot of things which affect cranes. Like, for instance, the wind will affect cranes. All kinds of things will affect cranes. What you've got to remember is that the Foucault pendulum, if you put that out in the open with wind around it and things like that, or other variables affecting it, it probably won't work. So we put it inside in a place where we eliminate these things affecting it. And cranes are designed to try to not be affected by external forces. But, crane operators will tell you when they go up in the crane, it moves a lot. In comparison to, say, wind and environmental factors, the 15 degree hour per drift, even though it is there, as I said time and time again, it's a very weak force, right? It's not like wind blowing at the crane and it's shuddering all over the place. It's a very weak force that is impacted on the crane.
You got it. This one coming in from, by the way, you guys all recently heard about the U.S. shooting down that UFO, right?
Yeah.
But wait, was it Mark earlier? I think you were the one that said, okay, that's right. So we've talked about this already.
Yeah.
Okay.
No, my whole point was, you're talking about the balloon, right?
Oh, I think there was something different, because there was the
okay.
balloon and then there was a
A
second
UFO.
thing.
Yeah.
A
That
UFO. Well, it's unidentified, so
But it was
identify it first and then come at me, James. All right?
unidentified, as in definitely aliens. This is coming.
Hey, whatever it is, just we don't have to attack one another, right? All people, if the government is made of people, we're all people. If we just choose to not hurt one another, there would be no hurting.
This one from
I'm on board with that, absolutely.
Yeah, let's
and,
go.
And
Nobody hurt anybody, all right?
And I love your take on science, like beautiful, perfect definition of science too. So
It was.
yeah.
I think that was just a moment. That was nice. And Photon Bread says, mad props to Nathan and Mark for coming prepared to have a good faith debate. David and Witsit just came to banter and ruins any real debate.
I gotta be honest, from my perspective, man, like I was trying to keep it on point at the beginning of the debate. Like we were like specific to the subjects. And I feel like people were just talking with like 7 different subjects past each other. And so I was trying to bring it down and point out the fallacies, which is the only way to have a logically coherent debate. So that's honestly what my motivation was.
Unfortunately, Witsit,
I
saw that coming from you quite a bit.
Yeah, I think from my perspective, Witsit kind of derailed the conversation a lot. We're trying to talk about things that's going into these fallacies which weren't actually true, and sort of just
I'll give you a chance to
going back to meta arguments and stuff. It just
I'll give you a chance to defend yourself, Austin, and then we got to move to the next one.
Notice
Sure,
how
sure, sorry.
I'll just say, you notice how I accounted for my behavior and I tried to explain where I was coming from, and they both just took it as an opportunity to talk about me. So I'll just let the audience soak it in.
Tons said, would you allow Austin to speak? We've tried to allow him to speak. Let's see. The other one is, we had another one. Timothy P. Southwick says, a drone programmed to y'all's believed curvature calculations is physical evidence. I don't know who that's for, though.
Oh my god!
I think that's for flat Earth. I'm aware that they've programmed drones to go higher and they see sort of curvature and stuff and bring objects back into focus. So maybe
See
that's what they're
curvature and stuff.
Well, I mean, they
Curvature and stuff.
basically observe curvature by they have a point. The drone flies higher. The point, the object comes back into frame. Then it goes lower. It can't see it. Is that what they're talking about?
They're
Look,
probably
I'm
talking
just-
about. It's okay. It's okay,
I'm
but
just
you don't
trying
see.
to figure out what the question is. Like, if
Right,
you
right,
know
right.
what the
In your
question's
model,
about,
you don't
then
see
tell us.
curvature from the height
Well,
that
Witsit,
drone.
if you want to go on about it, like if you know what the question is about, tell us.
Okay.
Yeah, I said that to you a couple times earlier. Witsit, just go ahead and say it.
I'm literally trying to. So, in your model, of course, the
Practicing.
curvature can't be observed from the height of a drone. He's probably trying to say the same very rudimentary point, which is since we go higher, we see further, which proves the globe. But again, on a flat Earth, if you go higher, you see further.
This one coming in from Tons says, not trying to be rude to Nathan, but I'm here to listen to Austin smoke these guys. Would you allow Austin to do that, please? He's barely said anything.
I think Nathan did
Austin.
great. I think
This
Nathan
place-
did great. You did
Gamer.
good, Nathan. You're really good, bro. It needed to be, you could take both of them on by yourself. So that's kind of how this conversation.
With your hands tied behind your back, Take that, Mark
chugging
and David.
Jameson.
Okay.
Hey, we're all trying to get an understanding of our natural world, right? We're all being scientists right now. We're trying to have discussion, bring reasons, and determine what we observe. I think everyone here is trying to be as scientific as possible.
Well, I mean,
say.
Witsit could probably talk more if he didn't, leave the debate and wander off, or just, submit that for consideration.
You guys kept running over me, so I stepped away. Yeah.
This one coming in from, do appreciate it. And I do want to say, hopefully folks, whether you're a flat earther, globe earther, all of the terms of endearment that they call each other, globies and flurfs, we hope you feel welcome. We really are glad that you're here, folks. And want to say, this one coming in from Displaced Gamer. It says, flat earthers, why do you weigh less, quote unquote, inside an airplane in the air than compared to, quote unquote, inside a house on the ground? This is a why question, to be clear. In other words, like, why? What's the reason for that?
Additional forces. Pretty simple.
Wow.
What's the answer then? What's the answer?
Wow.
So for one, if you're claiming altitude,
I don't want to interrupt Mark. He was about to explain. So.
If you're claiming altitude,
we
have
a question, Witsit. Can I answer?
Yeah, please let me know about how gravity gets weaker away from the center of mass.
Well, yeah, you got it.
I know your religion's simple, but my point is actually you have additional forces coming from the sky. You have a centrifugal translation of motion. You guys assumed I was talking about the plane. That was your mishap. And of course, you also have electric gradient going up, 100 volts per meter, increasing as you go up. And that's why we actually have a difference. And gravitational anomalies show that the measurements from the distance to the radius actually don't match the weight distribution. So that's a globe problem.
This one coming in from, do appreciate it.
Whatever.
Tons says, we got that one. Timothy P. Southwick strikes again, says a drone programmed. We got that one. This one from Polarity says, Nathan, what are your dependent and independent variables for testing and concluding the ether's existence?
Yeah, again. Oh, sorry, go ahead.
So dependent and independent variables for determining the ether. I would say that you can set up light and send it through a splitter, and then it'll return back to a detector and show maybe a slight drift, slight interference pattern, which might have something to do with linear light going against a vortex curved ether. So that might give you that slight variance.
You can also take like a vacuum chamber, right? And it would take everything out of the vacuum, and we see like electromagnetic fluctuations and energy pop into the vacuum. So the independent variable would be the vacuum itself. You're manipulating the vacuum itself, and it shows that there's not just nothing there, right? So the dependent variable, is the observable phenomena of there being electromagnetic fluctuations within a vacuum, or the Casimir effect with non-conductive plates. And you're having the independent variable of the vacuum. You manipulated that environment to remove the air, and you still have a disproportionate amount of electromagnetic energy, which is why we know there's something other than space and time, even according to mainstream academic physics.
The ether has to permeate that vacuum environment, and it allows those things to be in that environment.
Exactly.
This one coming in from, do appreciate your question. Coconut cream pie says, so because somebody says ether exists, therefore it exists. That's an appeal to authority. Beyond quotes, are there peer-reviewed articles on ether?
I had said that because this person says the ether exists, that would be an appeal to authority. Because this guy's an authority, he says this, it must be true. That isn't what happened in context at all. He said, and I quote, no scientists, quote unquote, say that there's an ether. So I corrected him by showing him very top tier physicists specifically saying there is an ether. The evidence for the ether is a logical antecedent of the fact that the vacuum has been proven to not be Newtonian emptiness. There's energy there that isn't predicted by particle physics or the amount of air there, and there must be something else sustaining that electromagnetic energy. That's the evidence.
And to throw it back, I could also say that I'm skeptical of space-time, and I would like a piece of fabric because I can't hold on to that fabric. I'd like to have a piece in my hand.
Be a fire suit to make.
Well, I mean,
Exists.
my name was brought up, so I should get to respond to that. But the question wasn't actually that. They asked for peer-reviewed papers, which I asked for as well, which you didn't actually provide. So I assume the answer is no, there is no peer-reviewed papers on your AFib.
There is literally hundreds of them.
Can you
This one.
can you reference 3 here?
Off the top of my, yeah. The quantum fluid, quantum field theory has about 20
Chat,
in and of itself.
In the chat.
Yeah,
Just
yeah, sure,
put it in there.
absolutely, absolutely.
Also, polarity. Sorry, I missed part of your question. They were the one that asked you, Nathan, about independent and dependent variables, and they also then had a follow-up question. So, in regards to the ether, they said, and regarding the ether, like, what effect does it have on anything?
So the ether would have something to do, or it has an interaction with light, and potentially some magnet. There seems to be like an electromagnetism connection, so it could have something to do with magnetism as well. But the main interaction with the ether would be light, and then however the like with the Elias effect with the Foucault pendulum. Affecting the swing and getting it to rotate at different speeds, even going backwards. That could have something to do with an alignment of the moon and sun, which are both their own independent lights charged, I believe. Again, the sky is a very frontier area, so it's a lot of hypothesis and conjecture. But I do believe that these two interacting forces cause some sort of other effect within the ether, but it's very frontier.
You got it, Ann. This question coming
just
in.
to mention, sorry, James, just quickly. I just looked at the paper that you sent in. It appears that the word ether does not exist.
Yep, there we go.
Yeah, it's a
I knew if
quantum
I
fluid.
said it, I was going to be called a liar.
Where's ether? There's no mention of
I bet if
ether
you guys don't let
anywhere
me
in this
respond,
paper.
you've never read the paper, but you just search the word ether and you think you've
Yes.
proven me wrong. Yeah, the author explains specifically it's a modern version of an ether, which acts like a fluid-like background medium. You can also read the next 2 papers, one from Harvard, which specifically says ether. You can read the second paper as well, which specifically says ethers. And I'm about to drop about 15 more. So thanks for playing.
No, wait. Hang on a second. You said that this mentioned the ether. It doesn't mention ether at all. Just because you're equating a phenomenon to ether doesn't mean that that's what they're talking about.
No, the
This is
author of the paper
conflation
said
I
that.
made earlier.
The author of the paper said it's akin to an
You
ether.
said you'd provide a paper with it. It doesn't have.
There's
it in
2
so
right there.
well
There's
done.
one from Harvard
Well
right there in the
done.
chat.
Yeah, well done.
Click on the one from Harvard. Why don't you do that?
The ether, what is being discussed nowadays as an ether has nothing to do, like Mark said, nothing to do with how it was described in the past. My understanding is that they are in a sense, what is it when you kind of
Got it.
Don't admit you were wrong,
the scientists are colloquially using the word almost tongue in cheek now to describe virtual particles. That's my understanding of how it's
Well, you're
being
wrong.
used now.
Per usual.
But there is nothing about the ether being used as a way to describe.
Okay, let me read this. The
forces
ether
that cause
invented
the
by
Earth
Isaac
to
Newton.
make a 15 degree per hour drift.
The ether invented by Isaac Newton, which, by the way, most Globers don't know that. Isaac Newton said, gravity cannot exist without a medium, and that would have to be an act of God. That's the stupidest thing I've ever heard, and no man with competent faculty of thinking would ever think that. Then he proposed an ether theory. I guess they forgot to teach you that in physics class. Anyway, the ether invented by Isaac Newton, the ether invented by Isaac Newton, reinvented by James Clerk Maxwell. This is the stuff that fills up the empty space of the
reinvented.
universe, discredited and discarded by Einstein. The ether is now making.
Reinvented means.
Why are you interrupting it? It's just a couple
Because
sentences.
you just said
Hold on, we
reinvented.
gotta
You know
move
what
forward.
that means?
Yeah, you're distracting again. Witsit, you're just wasting our time.
All right, I'm going
That's
to try
why
to
I
finish
used to
it.
interrupt. I'm sorry. Go
But
ahead.
it is.
No, you're
can't-
interrupting 'cause you
can't
know I'm about to
justify
press
interrupting by saying you're wasting time, because then both sides will start to do that, where they're like, "Oh, you're just wasting time. You're babbling. I'm going to interrupt you." Like, don't pull a T jump. So we're gonna go. Let's go to Ridge P. Says watching
Oh my God.
Witsit.
See, they get away with this, shutting it to the audience doesn't
You
get
just
to hear them be
interrupted
wrong.
someone,
I'm gonna
Witsit.
read it. I'm gonna read it.
Just-
So
you just
this is the
interrupted
end of
while I
it.
was
I'm gonna
talking.
read it. So it's discredited and discarded by Einstein. The ether is now making a Nixonian comeback. It's really the vacuum, but burdened by theoretical ghostly particles. Leon Letterman, God particle is the universe is the answer. What is the question? 2006 says the ether's making a Nixonian comeback, even though Einstein tried to get rid of it. Thanks for playing.
James, if I did that, would you have kicked me out of this place by now?
If you would have done what?
What he just did.
Finished what I was interrupted saying.
No, you had plenty. You had already shown the links. You had already made your point, and you're sitting up here wasting our time because
As
there's
you're just
nothing in
wasting
there.
time right now.
No. He said, let's move on. And you're like, no, let me go over it again. And blah, blah, blah.
Because
blah,
it's
blah,
not
blah,
fair to let you guys interrupt me and then just move past the point. That happened 50 times in this debate. So I said it.
I do want to get to people's questions rather than. So this is Rich P says, watching Witsit debate is worth every penny. Amazing. I wish I had half of his skill. You have a fan out
Thank
there
you.
as well, Witsit. This one from Jamanico. I didn't see a question attached. Let me know in the live chat if you want to ask a question in the normal chat, and we can read it as a super chat because it's in the super chat list. Question, the answer says just some paper for you, James. Thanks for your support. Appreciate that. And this one from Coconut Cream Pie says, did we read this one? They say, so because somebody says ether exists, therefore it exists. That's an appeal to authority. Okay, thanks.
Yeah, and that was a straw man fallacy.
Then this one coming in for, let's see, Tim Pryor. Good to see you again. Says, so let me get this straight. You claim you can bring boats back into view after going over the horizon with zooming, but not the sun? That makes no sense. This is why we laugh.
So the boats going over the horizon back in ancient Greek times when they would say, oh, we see this boat disappearing, bottom up, good eyes, by the way, to be able to see that. You see a boat disappearing bottom up, and then you say, okay, it's disappeared behind curvature. And once flat art kind of started taking off, people were zooming in on these boats and bringing them back. But the boat is not disappeared behind a vanishing point. The sun has 3 miles of ground and thousands of miles of sky. And then once they converge, once anything goes past that convergence point, you can't bring it back. No matter what zoom you're gonna apply, you're only gonna zoom in what is in front of, like looking at it this way, what is in front of this cross section. You can only magnify anything in front of that. Anything behind that is gone. You would have to move forward to then push this back, and that's or go up in elevation to push it back.
Nate,
And,
how many miles away do you have to be for that effect to occur? Just throw out a number.
For the sun to disappear?
For what you're stating to occur, how many miles away does an object have to be? And if you don't
on
know,
ground or in sky?
Give a range. Choose both, either one.
Don't they say we can see 3 miles at the you can see further if you zoom in with your eye.
That wasn't my question.
Miles.
That wasn't my question. Mark, do you want to jump in? I feel like I'm going to get myself in more trouble. I have a funny feeling. As when I get them like they're in a contradiction, I tend to somehow slip into a trouble. So
sorry, I was checking out these papers by Witsit.
Yeah.
One's from 1950, one's from 1976. Like, it's just a joke.
One's from 1999 and one's from Harvard. I just now proposed it. Okay,
So
the
one from
biometric ether theory, the
1999.
vacuum ether theory, loop quantum gravity, fuzzy space-time theory are all modern ether theories.
And they don't call it ether. That's the funny part.
They literally do. It's called
1999
biometric ether theory. I just posted the paper.
Yeah,
And
okay.
David,
Well, I'll check
the
out that
sun
one as
has
well,
a
but,
lot
you know,
more in between you and the sun versus the boat. But once they do go beyond that vanishing point where everything is the angular resolution is so small that nothing can bring it back.
Right. But things should be able to bring it back, because when something passes beyond the vanishing point, when we zoom into it, it comes back into our sight. That's how telescopes, that's how focus, like that's how our zoom works. And when we do see things vanishing into the vanishing point, like for instance, if you got, in Australia here, you got really long roads that are perfectly flat kind of thing. When you see something vanishing into that vanish point, it does not vanish from the bottom up. There is no force or no something that makes that car vanish from the tires going up. It just gets smaller and smaller.
It shrinks
and smaller
with
until
perspective.
it vanishes. Right, but
Still,
it
there's a
doesn't.
curvature
It doesn't.
that impacts the
Right,
placement
but
of
it doesn't
Over
vanish
water,
with
you
the
can get
tires
refractive
first.
effects that
can.
cause bottom up disappearance and temperature variation. Water has a high heat specificity versus land, so there's a greater temperature difference between the water and the land. So this can cause the temperature variation, which can give you bottom up disappearance. But if you're over land where temperature is a lot more consistent, you're not going to get that variation in temperature, which will give you more opportunity to see things shrink with perspective rather than shrinking bottom up.
But yet over land, you'll see stuff bottom up disappear as if over a curvature.
It can happen.
Yeah, all the
With
time.
By the way, I
yeah,
posted a
temperature can
2000
vary.
2018 Cornell University Vacuum Solutions and the Einstein Ether Theory. 2018 Cornell University.
What page? What paragraph?
It's the whole paper. That's the title of the paper.
Oh, this is a new link that you put up?
yeah, Cornell
Oh,
University.
it's a new link that you put up. Okay.
The other one was Paul DeRock. You don't know who that is, but emergent gravity theory, space-time foam theory.
Have ether in
Can I just
those
list a few of them
links,
off so the audience can look them up? Emergent gravity
Second
theory,
chance, yeah,
space-time
sure.
foam theory, causal dynamical triangulations theories, non-communicative geometry theory, relational block world theory, quantum graphitity theory, and that's again biometric ether theory, vacuum ether theory, loop, and quantum gravity.
Why would you not mention 2 or 3 and leave it at that? What was the point of you?
Because you said there's none, so we'll just name 7.
No, I said that your first links didn't suit. Now you're showing a list, and that list doesn't lead us to believe that within that article that you. No, I'm already there. There's nothing in that article that will justify your position that the ether explains why the Earth appears to rotate when it doesn't.
David, is it possible that maybe there was some things about modern ether theories you didn't know and you could research and learn them and maybe you didn't know about them? Is that possible?
Yeah, and it's possible that there are things about ether theory that do not agree with what you're saying. Did you ever consider that that's possible?
Yeah, sure. There are many different competing ether theories.
Yeah, there you go. Yeah. So now we go back to the original thing, which is that you postulate claims, and then Mark was doing even more of an effort to find it than I was, and he still couldn't find it. And now you throw up a 4th link that's just a list, and you're trying to rely on that list to be sufficient to say that it describes it in such a manner to prove your point that the Earth is flat or that the Earth does not rotate.
The link is not a list, just so you know. I can't drop links in the chat, but it's just from...
put it
all right, bro.
Form of a list when you spoke.
Waste of time now.
Get out of here.
What we have to do is, I forgot what I was going to say, but let's go to the next question. Largemouth Bear says, "Thank you, ballers, for making a few more flat earthers today. David, you are objectively lame. You should give this."
Oh, be nice.
Jeez.
No, I love it.
Okay.
Nice. That's not true.
They say, Mark.
Nathan, you're really nice right now.
Don't worry,
you
Mark.
keep on
They're getting to
them,
you.
Dude, you're going to see that it's going to...
Nathan's approach.
Politeness is unconquerable.
Yeah.
They say
last time we debate,
they've got words for you as well, Mark. But I'm gonna skip.
Oh, yeah,
I'm gonna skip that because they say Witsit. Wait, you want to hear the insult to Mark, David? Is that it?
Oh, he insulted me.
Hey, I want to hear the insults to Mark. Come on.
Go ahead, Mark.
Okay, as long as you're up for
You're
it.
much better at this than I am.
You guys have got tough skin, so you're They say Mark. Where is it? My eyes lost it. Mark, your dome is the only globe here. They love your bald head. Very sexy, like Stone Cold Steve Austin.
I wear it like it is. All right, it's right. Just more confirmation. That's all.
2R squared, bro.
Largemouth Bear. They also said Witsit and Nathan crushed it. Tim Pryor says, I think we got this one. So we get your claim. Bring boats. Yep, we got that one. Tim Pryor strikes again. He says, "No, you just regurgitate what you're told. You always claim flat Earth with no measurements. Measurements means numbers, which none of you have." I think they're saying none of you as in you flat earthers.
All plane survey data ignores any notion of the curvature of the Earth and literally makes up to 100 square mile measurements using plane survey horizontal level points. And that's how we do basic engineering for all trades.
You also have the 4 light experiment. That's 4 points of distance that are measured out, and then you can observe all of those lights over water, which is 70% or so of the surface, or however much. They're all planar, horizontal, linear, flat over water, and those are 4 data points at 5, 6, 7, 8 miles out. Grow to 1.
Rebuttals are not permitted, James. We have to proceed, right?
It just refracts everywhere perfectly. We get it. Your position's not original.
Are we allowed to, I'm sorry, James, are we allowed to rebut or no?
Your answer is refraction. We get it. Okay.
Let me think about that.
I would like to say I'm skeptical of a refraction claim being able to make that 4 light experiment. Any glober that wants to recreate that 4 light experiment, to scale and isolate the variable of refraction to show linear spaced lights that are exponentially refracted to all just appear even, magically, no, just to appear even and linear and horizontal. Please do show that to me, because I think that does show the planarity of the surface. The characteristic surface of water is planar.
All right. So, what's
Make
it?
it
Are
really
you aware
pithy.
that surveys? Oh, I'm sorry.
Really
Go ahead.
pithy. Short and sweet. It's
90
just we have more questions.
90-degree angles are used on surveys to ascertain distances, and that would require the Earth to have curvature, as the angles would not meet if the Earth was flat.
90-degree angles require curvature. What are you talking about?
In order for
Well,
the points to meet, my friend, in order for the points to
Geodetic
meet, you have a
surveys
problem.
take the curvature of the Earth.
Oh, just ignore plane survey. And then, yeah, I addressed that in my opener. If you had to listen, that's calculative assumption of geodetic observations, hijacking optical observations.
Yeah, this was my rebuttal.
not word
It's
salad,
not
slow it
yours.
down, we can
that's
move on.
yours. Yeah. So geodetic surveys take into account the curvature of the Earth, and they make accurate measurements of the Earth all the time. And geodetic engineering takes in the curvature of the Earth in order to do engineering projects all the time. Just because Witless is ignorant of this doesn't mean that it is actually
Name
true.
one.
They've been mentioned before. Somebody sent a post in with all of them, and you're like, no, they don't do that
Name
on
one.
vertical buildings, when they actually do.
Name one.
The Royal Academy of Surveyors.
That's not an engineering project.
Oh, I thought you needed. I thought you meant
Witless,
survey.
I'm not going to entertain your little.
You don't know. You
thing
just
here.
made it
Go
up.
for it.
Can I explain this real fast? Give me 17 seconds.
No. Let's
13
move on.
seconds.
I mean,
12
come on,
seconds.
this is
Okay,
getting
geodetic
ridiculous.
surveying assumes the sphere. It's a calculative assumption of sphericity based on optical observations, and it doesn't always match the globe. In fact, if you get within 85%, it's considered a success, and a weighted mean where you throw out the observations that don't match because the radius would be too big.
Mark, he debunked himself, but he thinks you didn't see it. He said based upon optical observations. Isn't that how we
Whoops.
slip?
This one.
Slip up right there, buddy.
We got to move forward. This one coming in from
Okay.
Coconut Cream Pie says, read my chats. It's just my name. Thank you for that. Polarity says, Witsit, you're too smart to believing what you say. You know the sun doesn't shrink to a point. The ceiling 6 becomes a 9, but it doesn't change rotation.
Yeah, like, okay, it's an optical effect based on an azimuthal grid of vision. We have an arc of vision with hyperbolic geometry of visual space. Now, I get that these are some terms that aren't familiar to
Word
people.
salad.
That doesn't make it word salad.
on.
You see how I was
is word
going to
salad.
say, I was literally going to
You gotta keep
say,
going.
Sorry.
I was going to say what Mark was going to say. I know that these terms aren't normal to people, right? Hyperbolic visual space. That doesn't mean it's word salad. You all have Google. Just go look it up, man. I had to read.
Yeah,
I had to
and
read through this book as
the
well.
thing
We have
about
to
it is
learn
that-
new
is that
things
it's-
in life. It's okay.
Witsit, it's not dependent on your like how you're standing. You can stand upside down. You can stand in any orientation. If what you were saying is true, see, why are you rolling your eyes though?
That doesn't
You're
make
speaking-
sense. The eyes are a
Speak-
circle, dude. They'd be the
So
same
what?
upside and
But
down,
your
up and
position
down.
No. Down
Yes.
is relative to where. No, down is relative to where you're looking. So you're looking straight ahead. Down is relative, like looking down to your feet and to your legs. If you're standing upside down, then that same angle will point upward towards the sky. If that were true, this is me once again trying to unpack your nonsense, and you're recognizing the contradiction, and I have to explain it in a way that is consistent, but it has to be dumbed down to your level. So you're using and you're memorizing,
All right, you gotta
you're
keep it
memorizing
pithy.
concepts, and then you go into the concepts, but you're trying to shoehorn your flat Earth interpretation into them. And I have to
Hyperbolic visual
unpack that.
geometry can be proven.
And I
Not
just
in
wanna-
that
I
way.
have to go
Ken.
to the next one. There are just so many questions. We have to keep going. This one from Tim Pryor says, flat earthers should not be allowed to say the word science. No scientist or any field of science backs up their beliefs. If you mention science, then you are using globe knowledge. Come up with your own stuff.
The Sorrow
tons of-
cycle, which science does talk a lot about predictions. The Sorrow cycle was derived using flat Earth culture. The Chaldeans, that they were a flat Earth culture. So a lot of this stuff does actually start with the flat Earth assumptions from our past, and then we build off of it. And then there's reverse engineering that goes on to try to ascribe things to a globe. But the flat Earth is able to make predictions and be scientific. We can use density and electromagnetism and these types of forces, thermodynamics. These are all in injunction with a flat Earth and work cohesively with on a flat Earth.
Yeah, I know many physicists and engineers that are true earthers. That's
This
just a
one
lie.
from Jay
Biblical
says,
earthers, true earthers,
Witsit and Nathan, why don't you guys reproduce the Mage 2 experiment by Mr. Sensible and send a camera attached to a balloon to see the curve?
We're actually currently sending up a balloon much higher than that to like 33, 34 kilometers and or 33, 34 miles actually. Like just over 30 miles with an infrared camera and a specific camera to see the stars that apparently NASA can never see when they go to space. We'll be making long distance infrared observations from over 30 miles up. And you guys will just, even with infrared, you'll say it's refraction. So for sure, you'll say it's refraction, but we literally are. We literally are doing a better version of that experiment or observation.
This
Cool.
one.
I mean, flat Earthers got a fine history of debunking themselves. We'll wait for your, this one.
That was creative.
This
Oh,
one
I mean,
coming
it's
in
happened. Thanks, Bob.
from
I think that was a
Coconut.
mockumentary hit piece.
Yeah.
But
They just say
Coconut.
phrases like robots.
Coconut Cream Pie says, what model do meteorologists use, flat or globe?
Oh, wait. Meteorologists use that's so funny you asked that. Thank you for asking that. They actually use weather balloon data, which actually is over a flat surface. That's why when they took the weather balloon data to put it onto a globe Earth, a blue marble, they had to stitch the flat map data together to map it around a ball. That's why when you watch the news, it's on a flat map projection for a local area. We actually get 99% of our weather data way more efficiently, even from mainstream academia claims that we don't get them from satellites, we get them from weather data on a flat surface. So that kind of backfired, I think.
NASA military,
Yeah,
NASA, the #1 user of helium, consumer of helium for all the balloons that they have. You have the ground towers that they use. That's all just like I didn't get to show it here, but underground sea cables use a flat water diagram in their cross sections and showing that stuff, but it's all using flat towers, flat maps. If you were going to drive across the United States, you'd use a flat map, and the weather that they show on the TV is on a flat map until they scale back and try to show you Canada and the U.S. and Mexico all at once, and then they
Sky Scion says, and we can't take any more questions, folks. Sorry, we're going to just read the rest, and then we've got to let these guys go because it's getting late. Sky Scion says, David and Mark, do you concede relativity says you cannot prove the orbit of the Earth from the Earth, and that everything on Earth occurs as if the Earth is at reset?
Okay, so we can prove the orbit of the Earth through the parallax motions of the stars. Like, that's not something that is hard to prove. We can also prove it by the way that the stars are obscured by the sun at certain points. There's no problem proving the orbit of the Earth. I don't understand why you would make that claim.
Because Einstein said, but when I was...
Witsit,
Witsit.
thanks, mate. Cheers.
Done, bro.
Settle down. And as far as sort of saying everything appears to be flat, our eyes are imperfect, and what appears to be the case, I might appear to see a mirage, but we know that's not really water when we see it. And observational data we can gather upon doing further investigation shows that it's not water. So this whole idea of what you see is what you get from optical illusions and stuff, that is an incredibly poor argument, because we know that the eyes can be tricked by multiple different optical effects. That's not an argument.
They asked you if you agree that relativity says everything occurs on the Earth as if the Earth is at rest.
Sorry.
That was the question. And then Einstein said, but when I was a student, I saw that experiments of this kind had already been made, in particular by your compatriot Michelson. He proved that one does not notice anything on Earth that it moves, but that everything takes place on Earth as if the Earth is in a state of rest.
Because of inertial frames of reference we've been over this. Because
everything appears stationary.
Well, I mean, if you're just going to hand wave away after asking a question, Witsit, why bother answering the question? So if everything is in the same inertial frame of reference, everything is moving with the Earth, on the Earth, then we can consider it stationary. But in fact, it is not stationary. And from the parallax motions of the stars, we know that it's not stationary.
I just talked to a professional astronomer 3 days ago who said parallax doesn't prove the orbit.
Well, you know what? Your appeals close to authority mean absolutely nothing.
You're just making
Which
stuff
is
up.
somehow a
Nothing.
question, a rare
Yeah, well,
question that was given to
this
us.
is the thing. Witsit has to have the last word every single time.
All right, you
It's
guys got it. You
absolutely
guys
just
got it. You
yap,
don't
yap,
understand
yap, yap,
relativity.
yap,
It's
yap.
okay.
We must
Okay,
move
so-
on.
There it is. Good job, Witsit.
This one from Bushidoki says today's scientists have substituted mathematics for experiments and they wander off through the equation after equation and eventually build a structure which has no relation to reality. Quote Nikola Tesla.
Who was that addressed to?
You guys.
Probably.
Okay, are you going to not
science
interrupt
side.
this time, Witsit?
Won't hold my breath.
Yeah,
But
Mark,
you wanna
I'm not
take
even
that
going to
one
try to address the question, so I'm just going to listen and learn.
Oh, okay. Yeah. So mathematical models can be incredibly useful, and yeah, I mean, it doesn't really substitute for experiments, but in some way, we've got to make models that can then formulate experiments of what we're trying to do and what we're trying to prove. Without mathematics, it's almost impossible. There are models that rely on math, sure, but this whole idea of, well, because we are trending or we're using maths to describe these things, then we've just thrown science out the window is just completely incorrect. And I don't think Nikola Tesla was correct about that. I really don't. There has to be some mathematical modeling of your what you're
Scientific
doing.
inquiries. Yeah.
Sure, yeah, it has to be there in order to make
Coherency.
to
make it
it's not just
coherent
that, but
and
you've
some
got
kind
to.
of-
Yeah,
Go ahead.
sorry.
I want to let you finish up. I just want to shortly. We have to move on.
No. You've got to quantify things in order to carry out those experiments. You have to.
Mark,
This one, I hate to do it, but we do have to keep moving. We've got just so many. So, Michael Lyon says, yeah, we have this says if you lived on a ball, the horizon would dip down the higher you go. Why is it on a plane at 35,000 feet? The horizon is at eye level. It's observably level.
It's not. It's not. Let me do this one. It is not. The thing is, your concept of eye level and level, you're confusing that with your sense of balance. And I brought this up many times. Anything that you look at, your direct line of sight, that is your eye level at that moment. Okay? So I can look at the horizon from 35,000 feet and I'm looking at it and it's at eye level. But as I stand, and I would have to zoom in because from such a far distance, the elevation from, let's say, 10 stories, from far off in the distance, that 10-story elevation is like a teeny tiny, 2 millimeter distance from the ground on the horizon. So the eye level that's parallel to that location is still going to appear to be essentially where the horizon is anyway. I know that you guys understood me, Witsit and Nathan. So Nathan, Witsit, don't even act like you didn't.
This one coming in from, do appreciate your question. Michael Lyon says, we got that one. Isle of Hager says, for both, most roads always go downward. That's clear empiricism. Sorry, no flatness. The sun doesn't fly away at evening either. It just goes down. Amazing.
if you look at a road, if you were driving down or through the desert and you were looking forward at a road and you're on like the highway, watch out for highway hypnosis, by the way. But if you're going down the highway, you're going to see that road. It's going to go up to your horizon. That's not like roads going down like that. That's a visual of a road going upward. I mean, if you're on a hill that's going down and you're going down the hill, it's going to go down, but roads can also appear to go up.
That's not how the curvature works, though, when you're observing it. The curvature is observed. The curvature is not observed. You can't see what's beyond the curvature. You know what I'm saying? It's like it doesn't even make sense what you're saying.
Unless there's like refraction or increased elevation or something.
Right.
Right, but even still, there's more curvature beyond that. So
yeah, and curve from where you are on a ball, everything would be curving away from you, curving down.
Right.
Yeah.
So your argument doesn't
going up.
No. You don't understand. You're standing from a height. No. You're standing from a height, 6 feet, 8 feet or whatever it is in the car and out in the car. Even though that height may seem minuscule compared to the, the vastness of the earth, there's still enough of that distance that point from where you're standing to the horizon is why it's appearing to go up. It's going up because you're standing this tall and you're looking at a road that is still level to the ground, like where your feet is.
You're saying that the visual
of the curvature being
perspective is
contradictory.
outpacing the curve of the earth.
Up to that horizon, up to that horizon, it is.
What the globe.
Oh yeah.
Yeah. Okay.
So how did you miss that?
This one?
Yeah, you missed that. I feel like you just overlooked
No, I agree. That would be the explanation, because you can't have something go up if the Earth is curving around. You would have to say that your vision is dominating over it's taking precedence over the actual physical curve of the Earth. Your perspective is giving you that, and your height.
No.
Your height is
only your height. Only your height. Because if
This
you were
one
to
coming
put your
in from-
eyes down to the ground, you wouldn't see any of that road going up.
All right, moving on.
Me Ethernet says Witsit railroad analogy fails. If you go high enough, you can see the parts of the rails that disappear at ground level, just like Earth.
But even if you go high enough, then you extend how much of the railroad you see, and at the limit, they still converge. So that literally just supports my point, and it supports that you see it over flat, Euclidean plane geometry with hyperbolic, non-Euclidean visual space. Okay. And just to clarify, Tesla didn't say that math is no good. If you ever read Tesla, he supported everything he ever did with math. He said they substitute experiments for math, and then in the end, they wander off through equations so much they have no relation to reality. He didn't say no math, but the railroads still converge as you go higher. That supports my point.
This one coming in from, do appreciate your question.
Not math for that ether affecting vision there, Witsit.
Never said that. Cool straw man, though.
Math for dark energy.
This one coming in, do appreciate your question from Coconut Cream Pie, says Witsit, stop spamming fallacies, show predictions. I don't know.
We have all kinds of predictions, like, for example, on the flat Earth, on a plane Earth, the Earth is actually the inertial plane or the block domain wall through the magnetic field, right? Which all magnetic fields have. And therefore, the magnetic field is going to get slightly weaker as you go further out south. Well, that's exactly what we observe on the Earth. The magnetic field in the south shows that it's significantly weaker than in the north, up to 30% weaker. And on the globe, it actually predicts symmetry with the dynamo model of a magnetic field. Just Google it, right? You'll see that it's supposed to be symmetrical, but it's not. It's weaker in the south, which works perfect. So that works with a flat Earth prediction. There's thousands of things like that you guys
just
pretty
hoopty magnetic declination in the south, right?
Oh yeah, it's just all over the place. The south doesn't work on the globe at all.
That's
this
a
one
explanation,
from Displaced.
South Atlantic anomaly.
Displaced Gamer says one day prompt should be, quote, a positive claim for flat Earth.
Wait, what?
I don't know what that means. This one from Zarzarin says Witsit, Einstein disapproved and disacknowledged the ether in 1906. Fact. Is there any fact you can give from this century without gish galloping?
Yeah, first of all, Einstein later said he misspoke when he disregarded the ether. We already read that. You should have listened. And he also said its story by no means finishes, continued by the relativity theory, and that space without ether is unthinkable. And I just dropped a Cornell University ether postulation and theory from 2018, and I actually listed about 10 of them from this century just a few minutes ago in the debate. So
you got it. This one.
None of it referred to the way the Earth moves, though, or the shape of the Earth.
He was disagreeing and challenging that an ether is even considered to be possible in mainstream science, and he's objectively wrong and ignorant on the subject.
Who
Mark.
Did? No, he didn't.
He said no scientists think there's an ether. It was disproven long ago.
No, Mark. Feel
no, I'm saying you're conflating the ether from back when Einstein disapproved of it with what they're calling ether now. And a lot of your papers say, we visualize this as ether. Not that it is the same thing, but we're using this word. And a lot of them are saying that. But you don't want people to know that. You want
what's the difference?
Exactly the same thing.
What's the difference?
But what the question is how is that ether? If you could just not interrupt me for a second.
You just lie so much. It's so hard.
Well, I mean, you lie as well. You're just absolute trash liar. So
You didn't even deny that you're lying.
What?
All right, come on, we gotta keep moving.
Wow, Witsit, you are terrible. The whole point is that they're using that word because it's familiar, but you don't want people to know that. You want it to be seen as exactly the same thing. But what you won't answer is how the ether is actually doing anything anywhere. You're just using it as a crutch, like magic, to explain all the things that are inconvenient for you, but never actually explain what this ether is doing and how it is doing it.
I can explain it all, but the problem is when I do it, you will say it's word salad, and you'll say I'm just making stuff up, and you'll dismiss it, and then call immediate interruption. Immediate interruption.
You interrupted him 4 times.
Let's give Austin a chance. Don't make me triggered.
So I can say it's actually a background medium, right? And so just like Sagnac said, who invented or discovered the Sagnac effect, which is what gyroscopes are used and calibrated and engineered with, he said it was a vortexual pattern within the ether that we're detecting the drift of. And that's what the Sagnac effect is. And that's what we engineer ring laser gyroscopes with, which detect that directly in connection with the 15 degree per hour sidereal rotation, which isn't perfectly 15 degrees. Actually, I can go even more into it. Tesla said it's actually viscous and tenuous beyond comprehension, and that thrown into infinitesimal, prodigious worlds of velocity, it manifests as matter. Electrostatics is the ether under strain. Magnetism and electricity is the ether in motion. Do you say I can't describe it? I can describe it, and you're going to say
no,
it's
but what you're describing is not indicated in the papers that you cited.
This coming in from alternate text says to globe and flatter sides.
Nothing you said are in those papers, Witsit. Nothing you said were in those papers.
It's like
because you're a liar. You're just a liar. You claim that these papers support you, and when they don't, you just basically refer to the ether that was a while ago and then conflate it with the sort of quantum mechanics that they're using today. It's a lie. You're a liar.
No, that's a straw man. I never said that
That's not.
Please stop. I never said that these papers support what I just said. I said specifically.
Oh, but you bring them up as evidence.
That's
great.
I want to give him a chance to respond. Hold on.
Oh, they don't support me, but I'm going to present them anyway.
You got to give him a chance to respond.
Specifically, I said there are many competing theories of an ether. And I said I have my own understanding. You said I can't make any claims about how it works, and I specifically claimed I can. I think that Tesla was very correct, except that light does not permeate the ether. It's an excitation or perturbation or disturbance within the ether itself. And it is illumination that is conflated into light. And that is actually a modality of the ether, and everything is. And in fact, that everything is unified under electromagnetic theory within a vortex and a toroidal pattern around that. And that's how everything works. So yeah, I have my own theory. There are competing theories. You said that science doesn't talk about an ether. I showed it. It describes exactly what the old ether is. And it says the word ether. It says we can't unify it with relativity, though, because we can't explain it. Thanks for playing.
But that had nothing to do with
it. Doesn't describe it as it used to be. That's a lie.
Is alternate Keck says to globe and flats. Do we have the ability to measure the distance to planets using amateur telescopes? Can we measure between continents as well?
I think you would need to assume size and distance and what you're looking at.
There's also
and speed of light.
There's also parallax. There's also
parallax is explained on a stationary Earth.
Oh, I give him a chance.
But it wasn't. Yeah, it wasn't about. Oh gosh. See, you just did it. So could you repeat the question?
Stop,
James.
All right. Ozzy and Talk said all those articles presume the Earth is a sphere. None believe that the Earth is flat. This is just a red herring.
Yeah, which is not to you guys, right? Yeah. So the good thing that if you understood basic logic, you would know that you can invoke evidence or a paper without believing every single thing that the paper says or that the person believes. If you think that you have to believe every single thing that someone says, and whatever Richard Dawkins thinks you must believe, Mark, that's your new belief. Whatever, that's not how it works. Okay, that's called an all or nothing fallacy. It's like sub-third grade. You can invoke what someone says. You can invoke paper. You can invoke an experiment. You can invoke evidence without invoking everything that the person believes outside of the specific thing you're invoking. And you can invoke hostile witnesses.
Never said that, but what you're doing is basically taking the paper.
I'm responding to the super chat.
Excuse me. You did bring up my name directly to me. So you're taking out what you want, you're cherry picking, dumping the conclusions, which is what you love to do, and then just cherry pick exactly what you want out of it and say it supports you. It's very, very known tactic.
No, cherry picking is whenever if I left it in context, it would contradict what I say. Meaning, if I say Einstein said the Earth appears to be at rest, but actually he didn't say it appears to be at rest. So this is you
Bob
have
can
to
show
censor
using
me because you
optical
know I'm just
experiments.
going
All
to
right, David, come on, it's getting bad again.
really fast.
Calm
So cherry
yourself.
picking is if I said, look, Einstein said that the Earth always appears as if it is rest. But if you went and read it in context, it would say, but it doesn't always appear like it's at rest. It has to contradict what you're saying. I'm saying Einstein said it always appears as if it's at rest. Not that he thought it was at rest, not that he thought it was flat. So when you say Einstein didn't think the Earth was stationary, he didn't think the Earth was flat, your own sources contradict you. That's a red herring fallacy and a straw man fallacy. Okay? It's very simple.
This one coming
it's
in
when
from
you pick out what you want from a paper.
Bands.
You'll get it.
Banna says, why does wait, actually I want to give, before we go to that one, alternate Keck, I feel like I accidentally short-sighted them. They said, to the globe Earth and flat Earth side, do we have the ability to measure the distance of planets using amateur telescopes? Can we get a yes or a no or an I don't know from everybody?
You have to make a bunch of assumptions.
There's
Like,
other
Not at the
ways we
same
can.
time, though. Let's go from left to right. Austin, yes, no, or I don't know.
no, not without a bunch of assumptions.
What about Nathan?
I'd say no as well. I mean, you're just looking at something you maybe have to have like a measuring device. I don't think you can. You'd have to measure other things and have other detectors and everything. But no, I'm gonna say no.
How about Mark?
Yeah, not accurately, but there are other methods of determining distance to planets. That's no problem.
And then how about David?
Yes, with other tools that are used in conjunction with them.
And then can we measure between continents as well? If you feel like your answer didn't already imply the answer to this, feel free to give an answer to this on whether or not we can we measure between continents as well.
It's very difficult to measure distances in water, especially in the southern hemisphere, quote unquote.
Anybody else?
You could maybe, I mean, like if you really wanted to like nitpick it, you could look at a landmark on land and then measure, okay, that's so far away. And then you go to that landmark and then look out at another landmark and say it's that far away. You know, scoot your way across a continent, something like that. But I don't think that's what he was asking. So,
well, I mean, with the power of telescopes, we should be able to see from one continent like South America to Asia, but we can't, and that's because the Earth is a globe.
Well, and there's
see infinitely through an atmosphere.
Opacity.
Any others?
Yeah.
Okay. This one from Banna says, why does the globe side really, I think they mean rely so heavily on presupposed theories? Isn't there a question that doesn't involve the Earth already assumed as a globe?
Well,
what other shapes could possibly be like coherent? Let's say it's a cube. If it was a cube, then you would get to a certain distance and then you'd see a 90-degree drop off. So it can't be that. Same thing with a triangle or any other shape that has a sharp change in the perimeter. So you're left with shapes that are, you know, spherical.
Gradual.
Or something like that, right? You know, so the curve that we see all along our vast Earth is consistent. We don't see certain areas that have a more striking slope than others.
You got it.
You know, that's it.
You got it. And might as well tell you a couple of quick housekeeping things, folks. In particular, all of our guests are linked in the description box below, and that includes the podcast. If you didn't know, we don't just call Modern Day Debate a podcast in the sense that it's like a podcast but on YouTube, but we actually have our own podcast. So it's all of these debates that are on YouTube. We put them on the podcast. It's 100% ad-free. So if you're like, hey, I don't like YouTube's ads or whatever it is, and it has all the intro music cut out. So if you don't like that, it's a very good experience. It's been popular. A lot of people have enjoyed it. So if you can find us on like Spotify, Apple Podcasts, all of these podcast apps. And the reason I bring that up is because you can also find Witsit's and Nathan's and Mark's and David's links in the description box there as well, or at least if they have a link at the moment, because some of the guest don't currently have a link. If you are watching live right now and you're like, wait, the guests don't have a link in the description box, you just have to refresh the page because I put them in after the debate started. So pardon my delay on that. But want to say thanks for all of your questions, folks. It's been a true pleasure. We appreciate our guests. So I want to say one last thank you, Witsit, Nathan, Mark, and David. It's been a true pleasure.
Thank you, James, and thank you everyone participating. Just a quick question, James. Are they doing a Discord after show? I don't know if they're going to do that or not.
I have no idea, man. I'm sorry. We do have a Modern Day Debate Discord as well. So guys, if folks out there, if you didn't know that, that is true. Highly encourage you to check it out. And also, last but not least, as I mentioned earlier, Modern Day Debate does have a TikTok account, and I have pinned our TikTok. I think it's at the top of the chat right now. It's certainly at the top of the description box. And I highly encourage you, if you have not yet followed our TikTok and you have a TikTok account, what are you waiting for? And the reason I say that is because once we hit 1,000 followers, we will be able to put these streams with these gentlemen, for example, out on TikTok so more people will hear them make their case. And so that our neutral platform can expand as we try to give everybody their fair shot to make their case on a level playing field. So one last thank you to our guests, though. It's been a true pleasure to have you guys.
Can we can we get like a closing word? Like just a minute to just.
I can give you 60 seconds each.
Okay.
Skip me.
So I thank you everybody for following along. Honest, open mind, inquiring. Science is wonderful. Thank you, James, for hosting this, and everyone for being here, having this discussion. James is going to have his next podcast about is Christianity rational? And I just really, y'all, if the Earth is flat, the 666 tilt, 666 curvature to the Earth, 666 falling around the sun, continuous orbit, bottomless pit around fire, all that stuff. The people that are in power, y'all, the Washington Monument, the barcodes, there's a lot of sixes and stuff in places, and these people are willing to use lethal force to determine policy instead of words. I think this is a lot about the human condition. We're either special, center of creation, or we're animals, and animals do all sorts of things, including take one another down. I think there's a lot of importance to this topic. So thank you, James. Thank you, everyone, for this discussion, and then people as well following along. So.
My pleasure. Anybody else? Otherwise, thank you.
I think you crushed it.
It's been a true pleasure. So I want to say thanks folks for watching. We appreciate all your questions and want to let you know, as always, we hope you feel welcome no matter what walk of life you're from, flat earth, globe earth, banana-shaped earth, you name it. We're glad that you're here. I'll be back in just a moment with a post-credit scene letting you know about upcoming debates. It's going to be a short and sweet one because I'm super tired, but I want to say thank you to our guests. You guys have so much energy. I'm blown away. So thank you guys. We'll be right back, folks. Stick around. Amazing, my dear friends. Want to say thanks so much for being here. Let me load Zoom back up, and then I'm going to take 5 minutes, and then I'm going to say, want to say, folks, we are thrilled to have you here. Thanks for all of your support. If you haven't yet, hit that like button. Seriously, that really does help. It's a small thing for you to hit that like button, so you're probably like, man, what's the difference? But it does mean a lot to us at Modern Day Debate, as we really do want to expand this neutral platform. It is a goal of ours. We are unashamed about the fact that we're like, yeah, we want to grow because we think we are providing value on YouTube. We think that we're providing something that's, you could say, not only value, but values-based, in the sense that our values are quite clear. We want liberty. We want freedom. We believe that our debaters were free from their first breath, and we want to keep it that way. We want to give everybody a fair shot to make their case on a level playing field. That's our goal on Modern Day Debate. We want things to be equal. That's why we at Modern Day Debate have neutral moderation where everybody gets their fair shot, as well as that leads into our second value, because a lot of people say, oh, James, but it's so dangerous. You know, if you let this position on or this person on, it's irresponsible. I'm one of the deplatforming crew, and James, you're so bad. You're so bad. And it's true, I'm a very bad man, but nonetheless, I've got to tell you, there's a reason for it, and it, you could say, corresponds or grows from, is a downstream consequence from the fact that we, as our second value competition, we think there's a value to competition. In particular, we believe that if you let 1,000 flowers bloom, there will be a natural selection of ideas. In particular, the best ideas will win out, and the worst ideas will fall by the wayside. The cream will rise to the top, and this competition will be a good thing because there will be refining. In particular, if there are dangerous views or dangerous individuals, it's good that we host them on Modern Day Debate, because on a neutral platform, they'll be exposed by the other debater that they're going against, and that's a good thing. Believe me. Some people are like, oh, well, James, like, you should like jump in and also expose them. And it's like, well, but that doesn't really make it look like they've lost the debate in a genuine way. Because it's like, well, if you lose because the moderator also jumps in, or if the channel is like, oh, we take a hard stance against this position, we think it's inappropriate, even though we platform. And it's like, well, it doesn't seem as if, for example, Frank exposes the dangerous view as if it's like a legitimate win anymore, because it's kind of like, oh, well, it's a platform that like openly admits that they're biased against the view that just got crushed. And so, you know, it's almost like if the refs were fixed in a football game, you'd be like, well, it doesn't seem like a genuine win. You'd want an asterisk next to their name if they won with biased refs in their pocket. So in the same way, like, this channel has to be genuinely neutral for a debate to be a genuine win. So in other words, like, yeah, we're like, hey, we're fully neutral. We're not like, hey, we take the flat earth position, or hey, we take the globe earth position, or hey, we take, it's purely like, hey, the debaters come on to make their case. We only have debates here on Modern Day Debate. There are no position videos where I come on and say, hey, my position is that, flat earth or globe earth is wrong, or, oh man, those flat earthers or those globe earthers totally blew it. They were so bad. No. Come on. YouTube deserves a better class of debate channel than that, and we're going to give it to them. We have big aspirations, folks. This channel, though I am grateful that we have hit, 93,000? I think it's like 93,500 we hit today, which is huge. So, like, just in the last 24 hours, I want to say thank you guys for subscribing. Seriously, your support means more than you know, and I've got to tell you, we're thankful for it, and at the simultaneously, we're excited about the future because we believe that our story is just beginning. We are actually small now compared to what we're going to become. We are going to continue to expand because that's what people want. We've recognized it. We've found that Modern Day Debate, it's expanding. People are saying like, hey, this is cool. Like, I want to come on your channel. People are reaching out to us now, and sometimes there are even people with major followings. People are getting on board, and so we're excited about that as we continue to pick up momentum. I want to say, though, thanks for being with us. I want to say hello to a few of you in the old live chat, and then I've got to go. But I want to say, Day Trooper GW, thanks for coming by. True Tech, glad to have you here. Ty D4L, glad you came by. Joe the Toe, good to see you again. As well as Into the Break, thanks for coming by. Thanks for your support. And good to see you, Iron Horse, you wily coyote. Thanks for coming by. God, Guns, and Glory, thanks for being with us. Into the Break, as well as Lauren Calfee. Thanks for dropping in. Am I saying it right? Let me know. Eric William May, glad to have you with us. TJ Davis, glad to have you here. Trillion, good to see you again. Sam Pedro, happy to have you with us, as well as Master Optics, glad you're here. Robert Page, good to see you again. Into the Break, good to have you. Dylan Motes, happy you're here. Mary, thanks for being here. It says best debate channel. Thanks, Mary. That means more than you know. And S. Campbell, good to see you here. Ryan Roberts, glad you're with us. What a world. Happy that you were here. Ty, let's see. Hillside, glad to have you here. Thanks for your kind words. Seriously, that means a lot. As well as, holy smoke, you've got a lot of people in chat tonight. Thanks for being with us, folks. Good to have you here. Charlie and Anchor in the Vale, thanks for dropping in. Solo and Gully, glad you're with us. True Tech, happy to have you here. Batman, good to see you. Huge fan of your movies. Also, thanks for coming in. Ms. Sweet, thanks for your kind words. Says James, I appreciate you so much. These debates are so great and some of my favorite entertainment. Get some sleep, bud. Much love. Thanks so much for that, Ms. Sweet. Totally appreciate it. As well as Amanda, good to see you. Says love and appreciate you, James. Thanks for that support. That means a lot. Really does. Thanks for helping us scope out our next spot for our next in-person conference this spring. Folks, if you didn't know, we do have in-person conferences. They're called Debate Con. It's a debate conference, in other words. And we are excited about that as we are pumped to bring debates in person again. Or it's a fun thing. We love doing it. S. Campbell, good to see you here. Says I miss Steven Scene. You and me both. Thanks for that. Snaptrap, good to have you here. Thanks for your kind words. That really does encourage me. It means a lot. Want to say I got to go, but thanks for being here. JJ Hempcrete Bear, glad you came by. Splatter IVXX, thanks for dropping in. Thanks for saying hello. Christoph, good to see you. Elaine M, glad you're here, as well as Lauren Calf and TJ Trusty and JF and God's. Let's see. Into the break, glad you're here. Let's see. Glad you're here. LRN News, thanks for coming by. And want to say thanks for all your guys' support. It's a busy time, as you know, but I've got to run because I am excited to pop in and say hello and then let you guys go. And I want to say thanks for all your support, though. We love you guys. You make this fun. We're excited about this upcoming debate. You can see at the bottom right of your screen. It's going to be huge. You don't want to miss it. So hit that subscribe button. And if you're already subscribed, check if you hit that notification bell for all debates, because that will make sure that you're going to see that notification for this big upcoming debate on Wednesday between Stuart and Aaron. You don't want to miss it. I want to say thanks for all your love and support, you guys. We'll see you at the next one. And keep sifting out the reasonable from the unreasonable.
Yeah. I'm not dying. Get out of here.
Amazing. As I said, my dear friends, thanks for all your support. One last reminder about that TikTok link at the top of the description box and pinned at the top of the chat. If you do have TikTok, it means a lot if you help support us by following us, as we're excited to be able to expand and live stream our debates over there as well. As for us, it's really just about the exposure. We really are excited that, hey, more people can learn about this neutral platform. So if you haven't yet, please do click that TikTok link and follow us there, as once we get to 1,000 followers, we'll be able to unlock that live streaming feature. So thank you guys. Love you guys. Have a great rest of your night.